So today we have RiskIQ, Phantom, ProtectWise, and Flashpoint. I think the key today is going to be all about collaboration and efficiency. Definitely see that with the partners that we brought in today. RiskIQ, we've been crawling the internet for 9 years, capturing enriched data and intelligence on the internet. You'll see that in the workshop today. ProtectWise, you're going to learn how to leverage technology that captures traffic, flows, metadata, and packets, and analyze them in real time, retain it indefinitely, and visualize it for immediate effectiveness, detection, and response. Flashpoint delivers business risk intelligence to help organizations protect themselves from cyber and physical threats and emerging from the deep and dark web. The data and technology and subject matter experts provide visibility into these inaccessible regions of the internet to help clients make informed decisions and mitigate risk. Phantom, finally, security orchestration and automation for hundreds of out-of-the-box integrations. Also, during lunch today, we'll take a break. We'll all go out, get lunch, and we'll bring it back in here. So food and drink is totally okay. Just, as somebody said to me, be adults about it, whatever that means. During the lunch, though, we've got Ryan and Alan from Nationwide Insurance that are going to be giving a talk on hunting drive-by exploit kits. So definitely a good thing. So without further ado, I've covered everything. Let's get rolling. Thanks.
Check. Hello? Check. Hello? All right. So these things work.
Sorry, I actually forgot something.
Uh-oh.
I turned my back and I realized. So this is very interactive. We're not going to just be sitting up here spewing a lot of words, right? It's okay to ask questions. If you have a question, feel free to raise your hand. We're going to throw you the catch box. So this is a microphone, and this will allow the whole room to hear any questions that you have. So I'd say ask questions just so you can have a foam box thrown at you. All right, thanks.
All right. Thanks, Brad, for the introduction. My name's Steve Ginty. I'm with RiskIQ. I'm the product manager for our Passive Total product and the co-founder of the Passive Total platform.
I'm Benjamin Powell. I am technical marketing manager, and I've been with RiskIQ for the last year, but security for the last 13 years.
So you're stuck with us for the next hour and a half, and we're going to kind of walk through methodologies for doing threat hunting using the data that RiskIQ brings together in the Passive Total platform. And we're going to walk through why it's important, how it can help your investigations, and hopefully provide you some insight into how we look at the world, how we collect data, and how we conduct analysis on that data to track actors. We have this really impressive setup, so we're going to be swapping screens, we're going to be using all the technology that they have here. But to start, for this portion of the session, you're going to need to log into community.riskiq.com. If you have an account, perfect. If you do not, you can go to /register and create an account. If you haven't set it up already, you should have been emailed this promo code up here, TW-Cincinnati 0318. That will unlock your community account and allow you to pivot around the platform at a much higher volume. The code is active for 30 days, so it basically gives you enterprise access to our data as a thank you for coming to the class and as ability to really dig through and use this when you go back to your organizations.
And if you already have an account and it was a community account, you can add the promo code under your profile.
As Brad said, we want this to be interactive. I can talk about Passive Total and this data for days. Benjamin can attest to that. We're going to go back and forth and walk through our methodologies, walk through what RiskIQ does. But stop, interrupt, ask questions. We're going to be doing some hands-on exercises. Really excited that you guys decided to come out and spend the next couple hours with us.
And in your packets, we put some exercises in there. We might not get to all of them, so the packet will have 3 additional exercises that you can take home. And these slide decks will be made available to you, so we'll have them also available that you can show people or look at the examples that we did before.
For those of you that were in Columbus, some of this content will be familiar. We have added some twists in there, and we've added some additional content in the packets for exercises, as Benjamin said, so we appreciate the return visit. So without further ado, what are we trying to do here? We're trying to walk you through data that allows you to really track threat actors based on RiskIQ's knowledge of what's happening on the internet. Our hope is that, big screen, is that you kind of learn what to ask of the data. RiskIQ collects a lot of data. We present that data to you as analysts. We provide you with a lens over that data to interact with it. But it can sometimes be overwhelming. We try to simplify that in our platform, but we want to walk through the methodologies, the concepts that I use as an analyst, that we came together and made the platform for, what questions you should ask that data, and how it can kind of drive your investigations forward. So for a hands-on training, we're going to walk through an email investigation. We're going to discuss some domain and whois pivots that you can dig through. We're going to probably do a guided walkthrough of our web crawling data and how you can interact with that and why it's important in your investigation. And Benjamin's going to talk to you very high level at the concept of digital footprints and how RiskIQ creates digital footprints.
So has everybody had the ability to log in? Does anybody need help? Okay, promo codes. Okay.
On that guided promo code.
Okay, so the promo code, you go back up, TW-Cincinnati 0318. Okay.
All right.
So with that, and this is where you add the promo code.
So if you already have an account and you want to add the code, you go into your account settings. There should be a promo code item that is empty. Hit the edit button, add the code in, hit enter. You should be good to go. So we're going to walk through some slides. We're going to start holistically. What is RiskIQ? What do we collect? Why is that data collection important? And how can you as an analyst use that data to your advantage? RiskIQ overall, if you think of us, we are a data collection company. We have products that service specific use cases, but underlying all of our products is this data that we collect as a company. And it spans the realm from crawling data to data feeds to Pasadena as to whois. We're bringing together as much information as possible to provide a snapshot view of the internet at a given time. With any collection, there are going to be gaps. We try to fill those gaps as we identify them, but our goal is to allow you to ask questions about what happened on the internet on a given day and get some context around things going on that you're seeing inside your network. We have 3 product sets, and I think it's really useful to understand how we look at that data. So we collect all of this data. The original use case that RiskIQ provided was what we call digital footprint. We collect all this data. We want to understand and help organizations understand what are your digital assets, web-facing assets online. What is your attack surface to an actor? How can we identify that attack surface and help you manage it effectively so that you can better protect your organization? From there, as we started to look at an organization's digital presence, the next question was who's trying to impersonate your digital presence, use your brand as a wedge in an attack. And so we have what we call external threats, people on the internet pretending to be you, mimicking you, targeting your customers, and conducting attacks against your customer base or your employees. How do we identify those, surface those to you, and allow you to mitigate them? And the reason this makes a lot of sense is once we know what is you, what do you own on the internet, it's not very easy, but it's a lot easier to then understand what you don't own and is pretending to be you. And then the final piece of our product set is Passive Total. This is our investigative platform. This is where we'll spend most of our time today. But we know what you are on the internet. We know who's trying to be you. The follow-on question is, what else is going on out there? Let's go investigate these threats to my organization. Let's use that same data that RiskIQ collects to understand actor groups targeting your organization. So we refer to this as digital threat management. We have a lovely slide here that outlines our data collection. Everybody needs kind of the machine learning, data science buzzwords these days, so we have those. We have a data scientist. We have some machine learning. We train models. We ingest all of this data. We try to understand, once we know what bad is, can we train models to identify and surface additional bad? It's only as good as the models you train. We spend a lot of time tweaking those models. But our goal here is to collect as much information as possible on the internet, crawl the internet, collect passive DNS data, whois, SSL certificate information, port data, to warehouse that data in a raw format, to then index what we think is useful and can help you as an organization detect threats, and then to surface that through our product set in a meaningful way that allows you to protect your environment. The fun part about this, and one of the main reasons why it made a lot of sense for PassiveTotal to become a part of the RiskIQ family, was this data warehouse. So I can go to our data engineering team and say, I have a use case. I want to go find X. And Adam can say, okay, let me go look at our data and see if we can service that use case. And since we store all of this data, we already have a corpus of data we can test this against that goes back about a year and a half to 2 years, all depending on storage. And so I don't have to have an idea of what I want to track or collect right now and start my collection today. I can go back and prove that case in our data set and then bring it to a product and make it available to organizations.
You did that with cookies.
And we will walk through a couple of data sets that exist in PassiveTotal today that weren't in the platform when we started. That kind of spun up from our CEO, Lou, saying, hey, this data would be interesting, and me saying, I don't know. And him saying, no, trust me, this is going to be very useful. And so the second half of this hour and a half, we'll walk through all of this web crawling data that we brought into PassiveTotal based on this data warehouse and how it's really helped drive my investigations forward. So we're going to start at the top. So we've walked through what RiskIQ is, what we collect. Now, what's the methodology we're looking at when we talk about threat analysis? And this is our really basic kind of word art scenario. And it really sounds kind of straightforward. And every time I present these slides, I think, this is stupid. But I really think it applies to everything we do as analysts. And while it's very basic, our process is always surface suspicious, collect as much data as possible, make an assessment. And this kind of chain of events is going to come up throughout the day and afternoon as we kind of bring all of this data together. But all we're saying is we have a starting point. We have a SIM alert. We have some type of suspicious activity. And we need, as analysts, to make an assessment on that. And in order to make that assessment, we have to have as much data as possible to understand, is this good, is this bad? So we have something suspicious. We go out and collect data. That data could be internal to your organization. That could be external from third-party feeds. That could be from a provider or a platform like PassiveTotal. You're going out and aggregating as much information as possible to get context around this suspicious entity that you're looking at. And the final kind of step here is take all that data, aggregate it, and as analysts, make an assessment. And this process right here is really why we started and created the PassiveTotal platform. It was because I was spending a lot of time, we had a lot of suspicious. Everybody had a question about something suspicious. We had a lot of data to collect. And everybody wanted an assessment, now. And the problem was we were spending most of our time in this collect data scenario, going out and aggregating as much information as possible to make an informed decision. And while that's all well and good, platforms, systems, technology can go collect data for us. That's not why our organizations are paying us as analysts to be there. They're paying us as analysts to make an assessment on something and to help determine what's going on. And so we wanted to kind of move down this curve and away from the data collection aspect and over to the make an assessment, make a determination of this entity that I'm looking at. And that's what we've kind of hoped to do with the PassiveTotal platform. You come to the platform, you query for an entity, we go out and aggregate the data, and you can spend the time doing your analysis. The reason all of this kind of works is no one can avoid the internet. We as organizations conduct business on the internet. Malicious actors have to use the internet to successfully conduct their attack campaigns. And so in some form or fashion, all of these activities, whether you're an organization conducting business or an attacker, leave some type of signal or a breadcrumb that we can use as investigators to understand who's targeting our organization. As RiskIQ, we now have the ability to use that same crawling technology to look at these signals that are provided to us. So what signals are we looking at? We have a lot of data available to us as analysts. We can go look at passive DNS data. We can look at whois. We can look at crawl data. All of this stuff can come together to really drive our data collection and our analysis. And the process that we like to apply to all of this data and these signals is what we refer to as threat infrastructure analysis. All it is starting with a single point in time and saying, what is this and what's connected to this? All of the data we're going to talk to today has some correlation. It connects in some way. And we can use those connections in that data to really understand or bring context to that suspicious entity that surfaces in an alert within our SOC. And so we like to talk about creating infrastructure chains. You can start anywhere in this process with any type of entity or data, and you can find a related piece of data that provides a connection. From there, you can pivot to another data set that forms another connection. And as you go through, you're creating what is essentially a chain of related data. Some of that data will have interesting context that may help your investigation. Some of that data may lead to a dead end. But what you're really trying to do is start with an unknown and try to find another data set that connects it to something known that allows you to make your assessment. Yes, this is suspicious. I need to spin up an entire incident response process to action it, or no, this isn't important to me and my organization. So it's really layered information. And this is important as we kind of get into this whole digging through the data in passive total and doing our investigations. We may start with a domain down here in green. And we may pivot to an IP address that it's been associated to. And that IP address may have other domains, and those domains may be associated with SSL certificates. The point here is as you get farther away from your starting point, your correlation starts to get a little weaker. And so, if I pivot to a domain to an IP, maybe I have a strong correlation, and there's something malicious there. If I pivot to another domain, maybe that's suspicious. Maybe it's not 100% malicious or certainly tied to my starting point. But all of these connections allow us some insight into what we're investigating and allow us to lay our own analytical rigor on top of the data to make that assessment. And so there are all these kind of second, third, fourth order layers of data that we have to dig through as analysts in order to make our assessment. Now, there are some caveats here. I said a little bit in the beginning, but all data sources have a bias. So you can come to me, and I will try to provide you the best picture I can of what I know about the entity you're looking at, but I can't have all the data at every time. It's why we partner. It's why we work with other organizations to aggregate data. It's why we bring in a lot of third-party feeds into the passive total platform. Everybody has a snapshot or an understanding of the internet from their point of view. RiskIQ thinks we have a pretty good understanding, but there's always going to be gaps. So as analysts, we have to understand that not everything is 100%. When you come to passive total, I will tell you exactly what I know about it, but I may not know everything about that entity. And you may have to go to other sources to get a complete picture. Assessing, so why do you want to do this inside of your organization? The process of threat infrastructure analysis creates a lot of interesting areas and opportunities for analysts. It can allow you to proactively identify threats. Not everything may be targeting you, or not all infrastructure used by an attack campaign may be used against your organization. If we start to build out these correlations and associations, what we find is we may find new infrastructure that an actor hasn't used against your organization that you can proactively block. You may be able to understand, why am I being targeted? Is this financially motivated? Is this, looking for, is this espionage related? Are they looking for, intellectual property? Is this competitive in nature? Are they looking to steal, R&D information? As you start to do these types of investigations, you'll start to understand overlap with other attacks that have previously taken place, which can provide insight into how you should action that within your organization. It also gives you historical context about the tactics an actor used. If I can tie something suspicious that's alerting in my SIM to a previous report that's been published 6 weeks ago about a specific actor group and the tactics that they use, well, now I have a little bit of a playbook to start to respond to that incident. Instead of just, oh, I don't know what this is, block it, re-image the box, it's, okay, this is the activity that this group usually uses. This is how we should go and start to action the response.
So should we do these screens and have them look at?
Yes. So that's kind of the setup to, why should you come and start to dig through data in Passive Total? Why should you as an analyst spend your time looking at these data sets at all? Whether you look at them in Passive Total or in other sources, there are plenty of sources for the data we're going to talk to. Why is it important for you to use this information? And that methodology that we just outlined is really the kind of underpinning of why an organization should start to dig through this data. Because actors make mistakes, they leave signals within these data sets. Those signals can be used to provide context to an investigation that you're conducting, and hopefully allow you to understand who's targeting your organization.
So if everyone can log into the community edition, and we want you to search for passivetotal.org. And then we're going to go through and explain the data sets using this domain.
So since we have this cool setup, we're going to present the Passive Total platform on one screen and our slides on the other and kind of bounce back and forth. We want to make this interactive. We're going to talk about a lot of data that you have access to. Some of this may be very straightforward and you've interacted with these data sets a lot. Others, this may be new to you. And so I think seeing it in the platform and how it comes together and talking about why it's interesting or why it could be useful in an investigation can be helpful.
And please ask questions. If there's something on the screen you don't know about a button or a certain area or about a data set and how best it can be used, please ask us and we'll answer those questions. Okay?
All right. We're going to start with what we call traditional data sets. And the reason we call this is traditional data sets is, people have been using things like passive DNS, who is malware hash correlation subdomains for a long time to do investigations. It's a tried and true methodology of take a command and control domain, take an IP address, go into a passive DNS system, conduct a query for historical resolution information, and start an investigation. We've layered this kind of infrastructure chaining methodology on top of these data sets and proven that they work, that they provide context to our investigation, and that they can help you respond to incidents. We break out traditional from what we call non-traditional, more web crawling data, because we've kind of taken this concept and pushed it to RiskIQ's crawler. So it may not be as familiar to organizations, and so we like to kind of set the stage. So we're going to start with passive DNS data. You come to Passive Total, you run a query, you get a lot of information. We started as a passive DNS aggregator. I'm lazy. I didn't want to go to, at the time, VirusTotal, Farsight, our own internal repository, Mnemonic, and a couple others, and query each of them and ask the same question. What do you know about this IP address? And then merge them into a text file, a spreadsheet, a notebook, what have you, and do that analysis. I would miss things, and it was a mess. And so I was complaining one day. Brandon, who is my co-founder, sat across the way from me and was like, could you shut up? This is not that hard. We'll program this. And I was like, okay, that's awesome. And so it was kind of the start of, let's make life easy for analysts. And what you see is when you come into the Passive Total platform, the first thing you see is the resolution tab. And that is our passive DNS data, and it is for A records. We strip out everything from our passive DNS instance in this tab just down to A records. Because when most people look at passive DNS, historically they were looking for domain to IP correlation. We have a lot more information in our passive DNS repository, and I'll talk to that in a minute. But what we're showing here is when we query for passivetotal.org, we're showing every IP address that we've ever seen associated with that domain in question. And so we see a lot of information here. I'm going to go.
Yeah. Oops.
Nope, wrong one. Technology. There we go. We have a running list of every resolution we've noted. You can see the IP address, the location, the US, the network, the first time we observed, that correlation to that IP address, the last time we saw it, and the source, who provided it. Is it from RiskIQ? Is it from Mnemonic, Kaspersky, Domain Tools, VirusTotal, what have you. And then some tags. What do we know about it? Who owns that IP address? In this case, you can see system tags for Amazon. And so there's a lot of resolution history. We host Passive Total at Amazon, and so therefore you see a lot of US-based IP addresses and Amazon infrastructure. If we were to kind of sift through this, the interesting thing would be, is there an outlier in any of this data? Does it switch to a different country all of a sudden? Have we seen any different infrastructure? You can see we have some DigitalOcean IP addresses down here. When we started out, we were low cost. We were not in the mood to spend money at Amazon, and so we were spending most of our money hosting at DigitalOcean. When RiskIQ acquired us, we rolled our infrastructure over to Amazon, and you can see that transition right here from DigitalOcean over to Amazon. Each of these things provides context, especially in an investigation. Who's hosting the domain? Is there a gap in the domain's resolution history? How many IP addresses does that domain correlate to? Each of those things is of interest.
What about the heat map in the time bar?
Would you like to?
Sure. So if you take a look at the top section, that's our heat map. And the heat map will show you all of the IP addresses we saw on that date. So if you notice, there's 2s up there, but if you come over and you see this little triangle, there's a little legend over here, and the legend will tell you all the things that are seen. So the circle, the half circles, is the beginning of a month when it's on the top. The bottom circle is the end of a month. And if you look at the little triangle, you can see that there was an additional IP address seen that day. So it can show you changes. So this is really good to look at. And this is showing 6 months worth of time at one point on the screen. Now, this time bar is showing all the data that we've collected. So you can take a look right away and say, oh, this has been around for a long time. And in the upper left-hand corner, you can see the first time this was seen online was on April 15th, 2014. Okay? And if I select any window of time down below, it will automatically refresh the data in all of the tabs, showing me just that period of time. And I can come in and select one or more areas to filter to a specific date range. So this is very important for your investigations, because you might want to narrow it down, just see certain time periods. So you can be very specific.
The reason passive DNS is very useful in general is the DNS system is dumb. It knows where passive total resolved to today. It doesn't know, when I go ask where passive total is, what it previous resolved to. So a passive DNS database is housing all of that historical information and resolution information in our system so that you can come back and view this history. Because if we go to look to type in passivetotal.org to a web browser right now, it knows that I'm hosted at an Amazon IP today and has no memory of what historically came before it. What we start to see with malicious attacks is actors may use the same infrastructure to conduct their attack. So we start to see overlap in IP addresses and domains that allow us to correlate additional information based on that resolution history. Let's go back to split screen. So a couple of things you may want to ask when you're looking at the data. How long has this domain or IP address had something resolved to it? History is always an interesting thing. And so as Benjamin pointed out in our passive total example, we go back to 2014 with our hosting history. That's a pretty decent amount of time. It's still kind of young on the internet. If you're seeing something with a large amount of history in our passive DNS repository, it's possible that it's legitimate infrastructure. Maybe it's compromised, but it could be legitimate. Time plays a big factor. If you see something that only has 6 months, 3 months, 9 months of resolution history in our database, that's a really young domain or IP address to have some resolution on it, and that's probably more interesting to you as an analyst. Additionally, overlaps in time period. Do same domains overlap at the same time? Is one malicious? Is the other one unknown? That's a correlation that can be interesting. You also start to see some interesting patterns. Do they change infrastructure a lot? Is there a lot of back and forth between IP addresses? Each of these types of things could give you some interesting information about time frame for an attack campaign.
Okay, and DNS?
From there, we move to the DNS tab. As I said, in our passive DNS database, there's a lot of information. But when we started, people were really only interested in A records. And so we kind of filtered a lot of this information out. We added into the platform in a separate tab because there's a lot of different stuff that takes place here. There are name server records, there are mail records, there are text and start of authority records. Each of these things will be shown in the DNS tab and can provide you with some interesting analytical leads. What we're seeing here is all of the history for passive total, all of the name servers, all of the start of authority information. There are 19 records, and you can see we start on DigitalOcean. We have some SPF for Google. That's where we were hosting our mail at the time. And you can start to see this changes over time. It changes to Amazon. And so this can start to give you kind of a historical progression of a domain. It can also allow you to pivot off of name servers, which can sometimes host thousands of domains that can be malicious and can be interesting avenues of investigation. So what are we really looking for in this, in this set of data, in this DNS data? We want to see number of records. Are there a lot of records? Is there a lot of history? Are they CNAMing this domain you're looking at to another domain, to a higher level domain? Is there a lot of swapping of name servers? Are there text records that have IP addresses that could be interesting? Each of these things is a pivot that you can make in the platform and that we're pulling out to provide context. I think the biggest reason that we see people use this data for is name server pivots and start of authority. You can see the start of authority record is an email address. We pull that out from our DNS database and allow you to pivot off that against our Whois database. And the reason this is useful is nowadays we find actors privacy protect their Whois information. But sometimes they provide a legitimate email address and start of authority in the DNS system because they have to. And therefore, we can use that email address as a follow-on pivot. Threat Connect has shown this a couple of times with their research into the Fancy Bear actor group, where they've used these start of authority email records to pivot and identify new and interesting domains. And so we're starting to see kind of this overarching DNS information play a larger role as actors evolve to our methodologies.
Subdomains?
Subdomains. We can pull out every fully qualified domain we know about to the domain in question that you query. The reason this is really interesting is oftentimes for attacks, an actor registers or stands up a single domain and starts and spins up a whole bunch of subdomain associations to that. In this scenario, you see passive total. We have a lot of legitimate infrastructure that relates to our passivetotal.org database. We have a certs endpoint, we have a host endpoint, we have some data nodes, we have an app server, we have Nutmeg-beta, which was an old beta platform that we spun up. All sorts of things that we're categorizing associated with our infrastructure. This is very useful for an organization to look at. It's certainly very useful when we're looking at malicious activity. Because what we find is there can be a lot of subdomains that an actor group uses that aren't targeting you, but that could be targeting other organizations and hosted on different infrastructure. So if I see a subdomain, I go and look at the subdomain tab because I want to start to understand, are there any other IP addresses associated with those individual domains that help enhance my, my investigation? And one of the exercises we have a little later will highlight how using subdomain information can really push forward your investigation. Whois information. Again, Whois database is just a who owns this record, this domain in question, who registered the domain. The same as DNS data, it's dumb. It only knows today's record. It can, those records last a lot longer, but the Whois system knows what it's been given right now. So you go into your command line, you type in a Whois for passive total, you will see this information. You will see that Elias Manousos owns the domain. That is our CEO. You'll see the RiskIQ's email address there. And we can start to ask questions of each of these things. What other domains were registered using that email address? What other domains were registered using that name? We can start to pivot through each of these entities and really start to understand correlations between ownership records. And so this information doesn't have to be accurate. Most times when we're looking at malicious attack campaigns, it's not. It could be a made-up address. It could be a random phone number. But going back to our earlier scenario of signals, what we're looking for is scenarios where an actor or an attack uses the same phone number, email address, what have you, to register domains, and we can use that as a pivot point to correlate our domain to other malicious domains in the system. Go back one more.
Okay.
And so what we're really looking for is uniqueness. And when we focus in on this, when I talk about uniqueness, we really look at things like phone number and email address. Because creating a new phone number can be easy, but people are lazy, and oftentimes they just copy and paste phone numbers in. The same with email address. You have to have an email address, so you have to create an email address. If you have to create a unique email address each time, maybe one day you're lazy and you decide to register 5 domains with the same email address because you had a wicked hangover from the night before, and you don't want to go through the process of having good operational security. Each of these areas allows us to really dig in and make a correlation for an actor group. So to tie this together to where we started in creating chains, if we're looking at passive DNS and whois, we can start to create these infrastructure chains very simply. We could start with an IP address. We could say, show me all the domains associated to that IP address. From there, we could say, show me all the IP addresses associated to those domains. Run another query against passive DNS and show us all those domains. And it starts to spider out and give us a graph of information. Now, as we said with our caveats, we may not have all of the information, and not every pivot you're going to do or every question you're going to ask the database is going to be inherently useful. One of the things I like to talk about a lot is frequency. How often have we, as RiskIQ, seen the entity you're looking at? Have I seen it thousands of times across my data set? That's probably not overly interesting to you. And maybe it is, but it's going to take you a lot of time to investigate each of those 1,000 leads. Have I seen this email address only used 2 times, 5 times, somewhere sub 100 times? That's probably interesting because we're collecting hundreds of millions of whois records, and if I've only seen it at that low a frequency, it's probably a lead as an analyst I want to investigate. And so across all of these data sets, I think frequency is something to keep in mind. If you look at an IP address and there are 10,000 domains hosted on that IP address, it may be interesting. But are you really going to look at all 10,000 domains? If you look at that IP address and it has 10 domains associated with it, it's probably a stronger correlation to what you're investigating, and maybe not a hosting provider, let's say.
Okay. Now for the fun part.
So that you're not just listening to me talk about this activity, we're going to walk through an actual investigation of the platform and allow you to dig through the data and kind of get a very quick understanding of how you can pivot through the passive total platform. I'll let you tee this up. This is your baby.
Okay, so what we're going to do is we're going to do a search for macy.dietrich50@mail.com. And we want you to go through and try to find out information about this. So think about this like you got a compromised device, and you're trying to investigate. You found an email address being the source of the compromise, and you want to find out, what is this? Is this something I have to be worried about? Is this a big attack, small attack? Who is it targeting? Tell me something about this threat actor. So try to go through and figure out if you figure something out. We're going to give you about 5 minutes to go through, and then we'll show you everything that we know about this threat actor.
I have that teed up.
And if you have any questions or need any help during any of these exercises, just raise your hand and we'll come on over and help you. Fancy. Perfect. It's in the handout. The plugins one. I have the screenshots in there. I want to go over the because I want to see. We want to jump that. And then Aaron will pick it up and send it out. Okay, awesome. Yeah, I think because it's figures. It's like tentacles. I have 20 steps, 22 steps. It's like, wait a second. You go down, back up, down, back up. Yep. What I want to dive in on is I want this possibility a map showing all the steps, so that when they're done, they can see, like, okay, then you know too, but you just show entities, just so they can see what they did. Oh, you want to make like one brick off each? No, I'm gonna have like that, showing we started here, we were done this way, we went back up, we were done, so then when they see it, they kind of understand the searches. Okay. And I'll put the map will link to the pivots. Okay. So then they can click on those and go and see them. That would be nice to be able to do that. To see your pivot map. See all of your searches that are pivot, but branch them out and see. Yeah. You've someone's asked us, but people have asked us to export. So the problem is it doesn't work with font style. Yeah. Even if once you start to tab it, it doesn't quite. You need the ability to do a tab open, but add it to your breadcrumbs. At least for some of this, like budget history. Like if you had your tabs into a breadcrumb, just drop it into it. That could be interesting. Anytime you get into like a little bit more recent, like it's a major URL change. It's a decent URL change. Yeah. It's like a habit hole. 2 months later, somebody goes, how much do you know? I never closed my tabs. I have like 1,000 breadcrumbs there. That would be you. Exactly. I actually closed out a couple of those just because, you know, I don't want to have too many things open. Okay, how's everybody doing? Do you need some more time? Did you figure out anything about this threat actor? So who was this threat actor?
Come on.
Fancy Bear. Yes.
There we go.
Okay, so we'll go through it, and we'll show you everything that we know about this threat actor. And if you have any questions, please raise your hand. We'll throw you the mic. Ask your question. We want to make this interactive because what we're trying to do is to teach you these methodologies so that when you see something, you can go through and do these investigations on your own and know, oh, if I look at this tab, it tells me this type of information. So you can start to understand the big picture of what this threat actor is doing.
All right, let's go to 2.
Okay, do you want to zoom more?
Yeah, let me. All right. So this is a fairly straightforward example. I think it kind of eases people into, into the platform if you're not familiar with pivoting through these data sets. I'm told some of our examples we did in Columbus kind of threw everybody into the deep end and was like, Godspeed. So we figured we'd start with this. You come into the passive total platform, as Benjamin said, you have this questionable email address, you want to know more about it, you query for it, and what do you find? You find that the email address is associated with 2 domains, wada-arnad.org and tas-cash.org. So we have 2 domains right away. That's low frequency. That's interesting. Both registered on the same date in 2016. Both listed in the platform as associated with Fancy Bear, espionage, and Russia.
And malicious. And they're red.
And so what we see right away is we have some insight. Okay, this is clearly interesting. I want to investigate each of these domains and see what more I can find out about this. So if we go and we click on the WADA domain, what we have is, first off, the heat map shows you that it stopped resolving to an IP address sometime back in September. So that's interesting. If you're doing this research right now, you know that it's probably historical and not an active campaign. We also have only a handful of IP resolutions. And we have some additional information with some subdomains. We have 6 subdomains in total in the platform. FTP inside www.inside www.wada and ADFS dot. Maybe they were testing something, who knows. Each of these things could be a separate pivot that you can make that may associate to another IP address. It could also give you additional things to investigate inside your organization. Were they using these for other parts of an attack campaign? Very quickly, you get some additional context. Now, we could also go back to our resolutions tab. With something like this, when we know these were registered at the beginning in 2016, I'd probably start my investigation in the first IP address they associated to. We could pivot off that 149 IP address, and what we find is it's hosting inside and WADA. We have a couple other domains here that are also being hosted on this IP address. As an analyst, I don't consider them really relevant to my investigation. The reason being here is if we look, the last time they resolved, we saw them in our passive DNS database associated with this IP address was 2014, November of 2014, almost a year and a half before our current domains are associating to this IP address. So it's really weak correlation. There's not much overlap in time. I would probably discount that. So also a good kind of example of why you may be looking at a very low level frequency 9 domains resolving here, but 7 of them really aren't relevant to your investigation.
Can I mention something?
Go for it.
So when you think of a domain, you can mark a domain as malicious because you can tag that. But the IP address associated with it, because it could be dynamic, those are generally only tagged as suspicious because, hey, it may be bad today, but 2 weeks from now it's been refreshed and it's okay. It's on a legitimate website. So just keep that in mind, is that the IP address at that moment in time might have been bad, but we only mark it as suspicious because it could be okay in the future or in the past.
We could go through and do the same process for this tas-cas.org domain. We have one other subdomain, FTP. With things like FTP, mail, www, those are kind of a mixed bag. The reason is a lot of hosting providers will automatically provision those fully qualified domains when you register any domain in question. So they may not be spun up by the actor. They may just be part of you registering the domain and associating it with infrastructure. So sometimes they're a good lead, sometimes they're not. But the final kind of step here is we have a passive total project that is public that provides you some additional insight into why this was labeled as associated with Fancy Bear. If you click on that project, you'll see that there was a Threat Connect report that we linked to. You can open up that link and see the report. Also in the project are all of the domains that were in that report and associated with this activity at that time. And so it allows you to have a grouping of additional indicators associated to your initial query. From there, we could then go, as analysts, read the report, get some additional context of why this is important or not important to your investigation, and continue digging, or we stop and make our assessment. But very quickly, you're able to aggregate a lot of information about this group and make an assessment. Great. Questions? Helpful?
now we're back to hashes now.
All right. We're going to walk through a couple more kind of contextual data sets that are in the platform and that you can use as an analyst to conduct an investigation. And then we're going to throw you in the deep end and give you a big thing to dig around the platform in.
So if you go back and you search for passivetotal.org, you'll be ready for us to go through the rest.
Kind of doesn't, very straightforward, but hash associations to infrastructure in question are a great correlation to maliciousness. And so we make that correlation based off of the entity you query. If you're looking at an IP or domain and there are a bunch of malware hash associations to that domain or IP, that's probably a good indication that something is questionable and you want to conduct further research. It could provide you with an insight into who is targeting you. It could help kind of fundamentally shore up your belief as an analyst that this is malicious. The reason this is effective is it can provide you insights into the type of organization or type of attack you're dealing with. Is the malware open source that's associated with this infrastructure? Maybe it's widespread and used by a lot of people. Is the malware financially, does the malware look to steal credentials or to steal banking information? Then maybe it's financially motivated. Is this correlated to some type of known bad code that's used by a specific actor group? All of those bits and pieces give you context about the threat you're trying to analyze. As you see in the platform here, there are no hashes associated with passivetotal.org. Yes. If you do sometimes query a legitimate domain, your organization may be in the platform. That may not always be the case. We use third-party providers like Proofpoint, Emerging Threats, soon to have hybrid analysis in the platform. Each of them make correlations to domains differently. We query on demand the domain or IP address in question to that third-party source and bring back those hash associations at that time. Proofpoint has a lot of interesting correlations. So does IBM to spamming emails. So just because you see a hash association in the platform to a domain doesn't always 100% mean that it is malicious in question. Could be compromised. So there are kind of questions you have to ask about that infrastructure as you're digging through it.
Open source intelligence.
Open source intelligence. This is basically our bringing Google into the platform. And so there's a lot of information publicly available to us as analysts. Everybody is pushing a report, a blog post, research nowadays. And so there's a huge amount of intelligence in the open realm that we can leverage in our investigations. The way we do that in PassiveTotal is we bring it in and call it open source intelligence. We used to have we still do, something called open source intelligence. It's a tab with a link that provides you with information on the report. We're transitioning these to projects, which I'll talk about next. But the idea here is that you can use other people's information, research efforts to help expedite your incident response and remediation. Hopefully, as you're going through the platform, someone has already looked at this information, and there is something in the open source that can give you insight into who's targeting your organization. It's a very robust source of data that can provide a lot of information to us as analysts. Things to look at: how many reports are available? What is the quality of the analysis? I'm making no statements on the quality of the information as we pull it in. As an analyst, I want all the information available to me. Who says something about this entity? Because it's appeared in an open source report doesn't necessarily mean that it's 100% accurate. There's a lot of open source reporting that gets pushed out and gets retracted. I think one of the big ones was a couple of years ago. A large consulting firm was pushing some media about attacks against the NASDAQ. And this was before some of the recent NASDAQ stuff had come out. So large-scale attacks against trading platforms. And I, at the time, was working at an Intel shop, and had a lot of financial customers. And they said, "What is going on? What is this? We see this reporting." And I had to say, I have no information about this. We have no known information about these platforms being targeted across our data. And I got berated by a half of my financial customers for a week. And then the following week, it came out that that report was actually inaccurate and was based off of a tabletop exercise. And there was no actual real-world attack against these institutions. And everybody moved on with their life. And so we have to understand that just because it is there doesn't necessarily mean it is accurate. And so, that's why we get paid as analysts. We get paid to make that assessment and to sometimes tell people that the thing the thing that your C-level executives are asking you about may not be a thing for your organization. So I always like to add that caveat. We provide a lot of information, but we're putting some of the onus on you as an analyst. I'll give you some information and tell you what I know as RiskIQ and what I think is valid. But it may not be important to your organization. You may look at that and say, I don't care. It's all about your risk profile and what you know are known threats to your organization. Finally, projects. We created projects as a follow-on kind of capability in the platform. The idea is you're conducting an investigation. You want to start to put that information into a packaged entity to help you keep state of your investigation. And so we have the idea of projects. All this is a way to share information with colleagues. It's also a way for us to share information and impart knowledge to you as analysts in the platform. So as these open source reports come out, we as a company go and we index the indicators out of them. We deploy what we call a public project, which is available to everybody in the platform. And we allow you to see everything that was discussed in that report in a project. The reason this is really useful is when I previously showed you a link for a specific indicator and said, yeah, this was malicious, and Palo Alto Networks reported on this a week ago. That was great, but then you had to kind of sift through the report and find the other indicators and figure out what the heck was going on. Now you can go look at that project, see the whole list of everything that encompasses that report. So maybe if you're looking at something that's malicious, you can go to the report, see all the indicators, pull out the indicators, the malware hashes, and kind of go do your own response. So we're trying to make things a little easier and impart context.
Now, one thing about public your projects, if you own the project or your team does, as new things, if you have it under monitoring, so each indicator that you add into the project, there's a little toggle to say monitor or not monitor. So if it's on monitor, if that domain comes up and there's a new IP, that's going to show up as an artifact, and then you can look at that and add it to the project. So it's like a constant query that's going on as the data's coming into the system. You have access to see those alerts, and you can go in there and investigate those things. So you don't have to run the queries again. So it's like an ongoing refresh of all that data. So it's not stale. It's not a point in time. It's gonna evolve over time.
And that's a good point. I find that I do an investigation. I'm sure you guys find this as well. You investigate something, you make a determination, you move on because there's 7 other things that you have to investigate or do at work. I would do this all the time, do this infrastructure analysis, walk away and forget to go revisit my research. 2 weeks later, that same actor group would use that same IP address, new domains would appear. I would miss them for 2 weeks until someone asked me about that, and I was like, oh, I'll go look. And then I, all of a sudden realized there was a whole other attack campaign that started that I missed. Bucketing things into projects, we flag them for monitoring, and then we send you an email, and there's an in-platform kind of alerts tab that says, hey, this happened. It may be interesting. You may want to go look at it. And it's to really help, maybe something 6 months ago you were investigating becomes a thing again. It's to really provide you situational awareness about what you've been investigating.
So now we're going to do a nice investigation. So
this one's a little more in-depth. It's still really focused on passive DNS and who is data. But there are a lot of kind of tentacles to this research. And actually, as we were setting up for this, I've been using this example for probably 9 months now. And I found some new things as I was going through the other day. So there's a lot of interesting stuff here. As you're digging through, focus on the data sets that we've talked about. Who is passive DNS, subdomains, DNS data, projects. The idea here is you're an analyst. You receive an alert about this news.googlesoftservice.net, and you're asked to assess the situation and understand what's going on. I'll give you a hint right away, questionable, because googlesoftservice.net is probably not a Google domain. So dig around through the platform using this as your starting point. I'll walk through a couple different avenues that I took and how I linked our data together to build out a full list of this infrastructure. We'll give you about 15 minutes to dig through.
any questions, please raise your hand. We'll come up and assist.
No, this is hybrid analysis.
Okay.
We're about to add this.
Anything cool you found?
Both timing and efforts. That didn't pull in. That makes me mad. Let me just open this up in a manageable tabs scenario.
Hi.
How's it going?
Sure, sure. So if you come over to so community.riskiq.com, okay? And then this is a promo code. So do you have an account? Okay. So then you're going to create an account, and then it's going to ask you for a promo code, and you're going to type it in. Yeah. So on all the, it's NKU public. And then there's no password. So it's TW-D. Yeah, it's on all the bottom of the slides.
I mean,
Yeah.
public.
Yeah.
Okay.
Okay. And then once you do that, then you'll have a whole bunch of queries to go through, and that will work for 30 days. Is there a way to save all of your tabs?
Yeah, you can save the whole thing in a tab file.
I didn't know that.
You can bookmark them all.
So-
I didn't.
so-
I don't
so-
think I bookmarked this one correctly.
So you mean all of the tabs in one bookmark?
No, so you just go bookmark,
Okay.
bookmark open pages,
Okay.
and it'll create it in a file.
Okay.
And then when you go into that file,
you can open them all
you
at
can-
once?
you can. Where did that?
Yeah, because I exported them all individually, had to number them so they're in the right order. And
I think if they're in a file, you can. Like, yeah. So, bookmarks. Next training example. I was able to a minute ago.
okay, well, I'll figure it out. That's good to know.
I'll try it in a minute.
Okay, so a lot of people are talking.
Yeah, we can get going in a second.
Yeah.
I want to just stage some of this out. Brad was taking some too. Like it. All right. Everybody able to find something interesting in this one? Any luck? The one question I'll ask the audience, and I'll walk through kind of a couple of the avenues that I found. Benjamin's created a kind of an exercise handout that isn't in your packets, but will be mailed out that walks you through all these steps, and I'll allow you to dig through this as well. Any correlation to what this is? Anybody able to find any kind of actor group, perhaps? Okay. And anybody find any open source information that gave you a very quick lead? Clear Sky, there are a couple projects that should give you some insight. I like this one because it ties in some very old infrastructure with some new stuff, which I think proves the point that it's always worth digging through this data. Go ahead and walk through one of many starting points for this. So our starting point of news.googlesoftservice.net, you come, you run a query for it. A couple things stick out right away. Not a lot of history in the passive DNS timeline. It's only been active since April of 2017, so not even a year yet. That's an interesting indicator right away. When we look at this, we're seeing in the resolution field some Korean IP addresses, a US IP address, and localhost. Signs that it's probably not legitimate infrastructure. On top of that, it's using Google's brand in some type of typo squatting scenario. It could have been legitimate Google infrastructure. I have come across Google domains that I'm like, there's no way Google owns that. And they do. So it's always worth a check. The first kind of check as an analyst I would do is in whois. Right away, we get some information that tells us it is most likely not owned by Google. We have a Gmail address and a Hotmail address, some junk characters on that top one, a lot of random stuff going on in the the rest of the record. So that kind of gives me a sense. Yeah, this is questionable. Let's dive right in. Before we start pivoting through the platform, the logical thing I would do is I see two projects that appear in passive total. We push a lot of intelligence to the platform, but we have a lot of security organizations that use the platform as well. Sometimes they deploy information that they know. And in this case, both Cylance and ClearSkySec, ClearSkySec, if you haven't heard of them, is out of Israel, have pushed some information to the platform about the domain in question. So we could go into each of these projects and get a little more color commentary on what they know. In the lead Casper scenario, they dumped a whole bunch of indicators, 119, including malware hashes, IPs, domains. So there's a lot of information there. It links to a Microsoft blog that walks through. Microsoft refers to this group as LED. And so right away, we have some context. If you didn't have a lot of time as an analyst, you could say, yes, this is malicious. You could probably go pull some indicators from the project. You could tell your detection teams to go look for any kind of activity to this additional information, and you're already kind of off to the races. If you have some time or a kind of a threat intelligence team that really digs in, let's go look and see how all of this correlates. And as I said, the starting point for me would be to look in who is. We know that Google doesn't own this. If we pivoted off of each of these email addresses, we wouldn't get anything in our database that associates to these email addresses right now. But if we pivot off of this phone number down here, we would find that not only has GoogleSoftService.net been registered using that phone number, but so has Apple. It's AppleAdWords.net. Okay, we're continuing our legitimate tech company typo squatting theme. Very interesting. Both of them have been registered as far back as 2013. So they've been around for a while as domains. So that gives us some more information. We started with something that's only been resolving since April of last year, so time frame. Maybe this is new infrastructure. Maybe this actor group's been using this infrastructure for a very long time. We can pivot off of Apple AdWords. When we do that, we see one resolution. It's to localhost, so that's not really going to be helpful. It's been around and resolving to localhost according to our passive DNS database for a long time. Sometimes not uncommon. Actors will register a domain. They'll set that domain to localhost, and then they'll add a whole bunch of subdomains, and those subdomains will correlate to valid IP addresses. So this is where we start to dig into each subdomain and say, okay, where does this other infrastructure lead us? We have led1.appleadwords.net. Kind of correlates to that LED public project. Let's go down that rabbit hole and see where that leads us. LED1 leads us to an actual resolving IP address. It's been resolving to this US-based 98.126 IP address. That IP address is owned by Crypt Technologies, a virtual private server hosting provider, fairly known with questionable activity. If you come across Crypt Technologies, it's most likely not legitimate business infrastructure. They pop up a lot in this. So that gives us an interesting indication that this is certainly probably malicious. Again, let's go look at what Crypt has associated with it. When we do a query of that IP address, we see led1.appleadwords and led1.googlefiles.com. And so we have another domain. And we can slowly work our way kind of down this chain, looking at each of these. And so already in a couple pivots, we've seen a couple typo squatting domains, a bunch of subdomains. We can grab that information, throw it into a project, monitor for this, monitor for those IP addresses for resolution change. And we have a lot of information. If we're really bored and want to really dig even more, we can go back to the subdomains here, and we could start to interrogate each of these subdomains. Game.googlesoftservice would lead us down a whole nother rabbit hole of resolving IP addresses, this time again to Korea. That Korean IP address gives us another game.google customer service. That domain leads us to more IP addresses, this 115.144 IP address. That IP address leads us to some additional questionable activity. But the interesting thing here is, we have a lot of information, a lot of ways to dig through the data and find additional correlations based on passive DNS, based on subdomains, based on who is. And we also have some information that says this is associated with bad activity in accordance with projects that were pushed via Silence and ClearSkySec. Now, you could take that with a grain of salt. You may not agree with what Silence or ClearSky has stated. So that's on us as analysts to make that determination. But holistically, this is certainly questionable and malicious.
Do you want to show the map?
Sure. And if you look at the full infrastructure, I kind of walked down the right-hand side here. There's a whole other set of stuff that goes up left. It spiders out. This was about 45 minutes of digging around the data, hitting dead ends, domain pivots, IP pivots, whois pivots that didn't really lead to anything fruitful. And so, it isn't 100% that you're going to click on something and find a good lead. But as you go through the data, you will find these correlations. Any questions? All right. So
Question.
who was it? I mean, this has some plugX correlations to it. WinNTI and LED are kind of the same group. So this has been associated to plugX at some point. No one's really published anything on this infrastructure. I like to use it because it's a little amorphous. It still is questionable, and still resolving. So Chinese-based.
And you can throw
The infrastructure's been alive since 2013, and it spun back up last April with some attacks. And I think those attacks were more East Asia-based, but it had previously targeted US companies. So kind of an interesting scenario.
just talking to the top.
Talking to
Just
the box.
keep it straight up.
like this.
Yeah.
So I see the hashes
Yep.
on that original search, and they all link to a login-only proof point thing.
Yep.
It doesn't log. It also is on VirusTotal. I Googled it, but there's no link to that. Can you explain what's happening there?
Good point. I wanted to point that out, and I had done that lookup. So we have an integration with emerging threats. Some people love it. Some people hate it. They have been kind enough to allow us to hit their database for free for anybody who queries for something in PassiveTotal and bring back their hash correlation. The downfall of that integration is to get the additional context, you need to be a Proofpoint/emerging threats customer and log into their portal. So it's kind of it's a little bit of a catch-22. We decided to go ahead with it because, again, I think more information for an analyst is better than no information in this scenario. To your point, it is available on VirusTotal right here. If we look in the behavior section, it is linked at the bottom, news.googlesoftservice.net. The caveat with VirusTotal is I'm hitting their public APIs. And their public APIs don't always make the best correlations between domains in their behavior and sandbox analytics and the malware hashes, so sometimes they won't come back. I'm actually going to have our team investigate this because this should technically have come back since it's in VirusTotal. But there are some times where we can't get that based on the API data they're feeding back to us.
Correct.
To go to VirusTotal. We're adding in, and this is one of the reasons we're working with hybrid analysis to hit their sandbox as well now, to add in a third kind of option for additional context. For those of you that hate our emerging threats integration, there will be the ability to configure it off. I like it on. I then go do the poor man's scenario and copy and paste that hash into Google and see what I find. Sometimes there's some good information. So it's a little bit of a catch-22, but yes, thank you for pointing that out.
Just throw it back.
Just making me throw the catch box too.
Uh-oh.
Perfect.
There we go. So a lot of information on this. I think it's a really good example of how you can dig through the platform.
Okay.
We're going to roll through some slides now on. I'll go back to the last one. So the second half of this conversation is more around RiskIQ data and why we decided to bring some of our crawling information into the platform. And so we've talked a lot about making these correlations and how the data has connections and how we can use those connections to surface analytical leads. But what we've found is that actors know how we track them, and it's a cat and mouse game. And so they may privacy protect their whois data. They may fully segment their infrastructure so that they're not overlapping domains on IP addresses. They may use kind of quick hosting providers and spin up and take down infrastructure very rapidly. And so we're starting to see visibility gaps. And there are visibility gaps in PassiveTotal in certain data sets. And so we wanted to bring more information to bear. With our goal here is as actors close one door, another door opens. They leave some type of breadcrumb behind. And so we're trying to close that visibility gap using RiskIQ's crawling data. And we talk about our crawling data in a lot of different ways, in host pairs and trackers, SSL certificates, cookies. And I'm going to walk through what each of those kind of data sets mean, why they could be useful to your investigation, and how to kind of apply that data in the platform. So RiskIQ has virtual users. We deploy them to scan web-facing assets. This is part of our digital footprint product. And I'm taking that information as we scan, and I'm indexing it, databasing it, and bringing it into PassiveTotal to provide threat analysts a lens into that crawling data. Next slide. Basically what this is it is a headless browser that goes out and crawls a web page and interacts with that page the same way a user would. I can tell it to 10 links wide, 10 links deep, and really start to walk through a web page like one of your normal customers would if you have a large web-facing presence. When we do that, we're capturing a whole bunch of information. Key to this is we're capturing the document object model of the web page. We're pulling that down and we're indexing that for a lot of information.
Now, one other thing is, think of it like the intended victim. So it goes out there as well, and it acts like the intended victim. So different operating system, different browser types. It's not just give me everything. It's different ways. It's clicking. Maybe different browsers will go out and hit the same website to get different pieces. So it's bringing all that together.
It's useful. I don't have enough time. We'll skip this.
Okay.
We're going to walk through passivetotal.org from the view of our web crawler. So we've been looking at it all day today in our browser, in the platform. I'm going to show you how we go and collect some of this information right now.
So do you want me to do 2 screens?
Yeah, please. Okay, so we see passivetotal.org up here on the screen. I deployed one of our crawlers to go out and crawl that web page, and there's a lot of stuff going on in the background. Like I said, when we go out to the page, our first thing that we do is we pull down the full response and document object model, and we store that. The reason this is interesting is there's a lot of unique pieces of that page that we can index out of that document object model. Things like links. What does this web page link to? In the case of passivetotal.org, when it was live and not redirecting to community.riskiq.com, it was linking to RiskIQ. So I now have a relationship between passivetotal and riskiq.com because I'm linking to content off of my website. It also has dependent requests. What did I go out and grab from third-party websites to render the page? In this case, I sent the crawler to http:/passivetotal.org. It redirected it over to HTTPS. We see that in the crawl. And then we also see that it went out to typekit.net and pulled down a specific piece of JavaScript. And that specific piece of JavaScript was a custom font package that we use because our developers are fancy. But that relationship now exists between passivetotal and typekit. We also index cookies. We're not indexing the unique cookie value, we're indexing the cookie name. So in this case, 2 cookies were dropped, AWS load balancer cookie, and also a Whoopr tracker cookie. We use Whoopr to understand who's coming to our website and interacting with it. We also use AWS for our infrastructure, so both of those cookies appear associated in this crawl. We also grab the SSL certificate information. And this is useful in understanding the type of certificate used to encrypt our site and our communications. In this case, it's passivetotal.org. But we see this with actors a lot using certificates to make their attacks look malicious. All of this comes together into passivetotal to form specific data sets. And so how do we operationalize those things? We operationalize what we just talked about in what we call SSL certificates, trackers, host pairs, web components, and cookies. Certificates, very straightforward. We're pulling down the certificate association. We're indexing out the unique attributes of the certificate. We find this is very useful because actors are now encrypting or creating certificates for their attacks to encrypt their command and control, to make their attacks look more legitimate, to actually operate on the internet, since Google is blocking sites that don't use HTTPS now. And so we start to see correlations between a certificate and an IP address. And those correlations can be very useful.
So one thing to mention is the same type of pivots like what you find with Whois, like pivoting and finding additional things, you will be able to do with the certificates based on the names and things that are in there. So a lot of the threat actors they make their own certificates. It might be a self-signed certificate. They might use the same stuff, for example, inside there.
So you can see here the certificate collection for passivetotal.org. Certificates are getting very interesting nowadays. Let's Encrypt provides free certificates to anyone who wants to go and create a certificate. That's great for security. That's also great for bad actors. We're seeing a lot of Let's Encrypt certificates being used as a part of attack campaigns. It's only going to get worse. Let's Encrypt will soon allow anyone to create a free wildcarded certificate, I think either this week, next week, or the week after. And therefore, instead of having to create unique certificates for every domain that they want to use and make look legitimate, they only have to create one for their higher level domain and then create a whole bunch of subdomains that also use that certificate. So we're going to see this become much more pervasive as this happens. It's a free service. Hopefully, as analysts, it works to our benefit. We can use SSL certificates to start to track these actors.
Okay, trackers.
Trackers. These are unique codes that we index out of that document object model. These are clicky IDs, New Relic IDs, Google Analytics codes, social media handles. Anything that is unique to an organization that's an attribute of that website that we can database, we pull out and index and put into our database. The reason this becomes interesting is we see a lot of bad actors start to copy the HTML of legitimate pages and stand them up on their malicious domains. PayPal is a great example. A lot of people like to typo squat on top of PayPal infrastructure. They like to do credential harvesting on PayPal accounts. They stand up PayPal, they copy the HTML of the PayPal login web page. They stand it up on their legitimate site. They forget to remove the trackers. And so I can take the Google Analytics ID, and I can pivot and see legitimate PayPal infrastructure to typo squatting PayPal infrastructure. It's a very good correlation from known good to known bad. It's an interesting starting point if you don't use the tracker database that much in Passive Total, is to take your brand, your organization, and look and see if that tracker has been anywhere in our crawling data. I think I kind of talked to this. So we take each of these, using our kind of correlation from the beginning, the document object model, we index out unique trackers, and that tracker correlates domains for us now. So now we have unique relationships between those domains. We take a certificate, we index out the unique facets. Anytime we see an association to an IP address, we make that correlation SHA-1 to IP address. Those IP addresses could give us additional domain associations. We see this with a lot of Russian actor groups. The satellite Turla group in particular has been very interesting to track using reuse of certificates. And so it gives us a new avenue to bring crawling data layered over our traditional IP domain whois information and start to correlate attack campaigns. Host pairs. This is a unique parent-child relationship that we create when we crawl something. So I said we pull out links and dependent requests as we crawl a web page. We make a database out of those showing those relationships. So passivetotal.org would be the parent. When I redirect and pull information from typekit, that is the child. And so we're creating this sequencing information. And it allows you to understand a lot of redirection, a lot of compromised infrastructure. Is someone compromised a legitimate site and sending your users to a malicious web page? You can see that sequence if we crawled it during that time frame of that malicious redirect. So very interesting in kind of compromised infrastructure. And it allows you to understand the makeup of pages as well. So things to start to think about, especially with crawling data in general, frequency. How often have I seen this in crawling the web? We do billions of requests a day. And so if I've only seen this correlation a handful of times, that is interesting. And so you want to keep frequency in mind when you're doing this. There's a lot of legitimate stuff that you see in these types of correlations. Everybody links to Facebook, Twitter, social media platforms nowadays, ad platforms. So you're going to see a lot of very common things in there as well. One of the big things to look out for is date range. Has this site redirected to another site for 1 day, for 2 days, for 3 days? Most redirections that are going to take place and dependent requests that exist over a long period of time. And therefore, if you're seeing a small window of time, that's probably very interesting to investigate. And so how do we make this? We make our host pair database by taking links, sequencing data, and dependent requests, and merging them all together into our host pair database, associating domains and IP addresses.
So we have about 5 minutes.
Our host pair database then shows up in the platform associated with a first scene, a last scene, a direction, parent or child, and the cause. Was it a top-level redirect? Was it a script? Was it an image? Anything we know about that redirection or about that link that we pulled in, we will let you know what that kind of cause was and give you some insight into the makeup of the page.
Web components?
Web components is kind of informational, I would say, for the most part. But this is the underlying infrastructure of the page we crawled. What did we see associated? What ad services? What server configurations? What type of WordPress is it running? What type of JavaScript are we seeing? All of the underpinnings of a page we crawl gets put into web components. And up until about mid last year, I said this was really just something that provided you some context about the page you're looking at or investigating. And then CoinHive came along. And all these in-browser crypto mining scenarios started to happen. And we were able to start to really look at all of the scenarios where we've seen specific CoinHive's JavaScript library inside of a web component and what pages they associate with. And so you can start to see all the pages that we've crawled where we've seen that JavaScript library. This has exploded because after the CoinHive scenario, it was everybody who had some type of mining component was basically copy and pasting that code and throwing it in, throwing it into a browser to improve their mining capabilities. But it has some scenarios where you can start to look at unique libraries, technologies. What's vulnerable of those technologies that you're seeing on that web page as of right now? And so it provides some good context as an analyst. And finally, cookies. We're pulling out, as I said, cookie names. And what we've seen lately is actors using these cookies in interesting ways. At first, I thought they were typo squatting or kind of cookie squatting legitimate web cookies or fat-fingering cookie names. And what we're seeing is a lot of actors are using cookies for persistence and to fingerprint people that they infect when they come to their compromised website. And so Ocean Lotus, that was talked about in November of last year, was a prime example of this, where they were using specific cookies that were cookie squatting Cloudflare cookies that would be dropped on a machine as a part of their fingerprinting campaign. And we were able to tie together all of this compromised infrastructure based off of a handful of cookie IDs. And it's on our blog, and there's a project available for it, but it walks through how these cookie names that these actors are using can be used as a correlation point. We also saw the Russian group Turla was pushing, they were using things like, I think it's PNP sesh ID. PHP sesh ID is a common cookie name. You'll see it a million times across web pages. They were using PNP sesh ID as a cookie that they were dropping to fingerprint people they were targeting. I thought it was typo squatting. What we really figured out, or cookie squatting, what we really figured out was they didn't fat finger it. They couldn't have it be PHP sesh ID because each time that someone came to a legitimate site, the cookie would be overwritten. So they were just using something that was semi-like a common cookie. You would never know if you were looking at that it was an indicator of interest, and you could pivot off of that and use that cookie to identify all these compromised sites. So a lot of interesting ways to dig through this data.
Okay. And then
we're coming up on time, so we're going to stop here and pass it over to some of the other presenters. If we have some time in the afternoon, we'll come back and I'll walk through a couple examples of this crawling data and these investigations. It takes a little more time to dig through the data, but I think it's really relevant to investigations nowadays. Hopefully this was useful for you guys, gave you a little level set of where we're going with the day. We're going to bring on our partners now to kind of walk through their platforms, and then we're going to bring it all together, how the investigations that you can do with our data play into your whole security ecosystem.
Benjamin, thank you very much. That was great. As you said, we're going to hand off now to ProtectWise. They'll be coming in to showcase some things, again, in very similar format using their platform. So the agenda was up there. I was going to say we're saving break time until after ProtectWise. Again, if you just need to slip out for whatever reason. So hand it over to them.
Excellent. Thank you. Gentlemen from the AV room, we're going to need AV on this one. Thank you. He's a stud, by the way. Hey, let's give it up to that guy. He's the man behind the curtain over there. Excellent.
Has the box been thrown yet?
Yeah.
Good.
So rather than us bore you with what we do, we're going to give you a 2-minute video, and actually was put together by our CTO, so nobody better to tell you what ProtectWise does than Gene Stevens, our co-founder. So we're going to start off with a little video of what we do, and then what the goal for today is going to be, we actually, all of you today will be empowered to be able to log in to what you see today, so you'll all have access to the platform. You'll all be able to go in. We have 2 exercises. What we'll do during our sessions, we'll walk through the first exercise, and then the second exercise will be in your inbox, and at your leisure, you can go through it, right, at your pace. So we'll be here this afternoon, be able to walk you through it, but you'll get some exposure on how to walk through it on the first one. Anybody a large in the room? We got any larges? There we go. It's a good shirt. None of that beefy tee crap. It's that American Apparel stuff. All right, so good stuff. I got more shirts too. And women's cuts too. So if anybody needs a women's cut, I can send you one. Just let me know. All right, so yeah, let's start off with what ProtectWise is.
I think it's best to be understood that ProtectWise is on a mission to fundamentally change human experience and security. What we found out was that the problem wasn't really a technology problem inside the organization. It was a delivery model problem. What we did is we found a way to move that core security functionality away from racks of appliances to the cloud. At the end of the day, what we give people are these lightweight software sensors. They are tiny, and they're meant to be massively distributed across the entire organization. And what they do is they do packet capture. And we compress, we optimize, we stream that data to the cloud in a real-time fashion and run it through a suite of threat detection capabilities. But what's more interesting, in my opinion, is that we actually keep a copy of all that high-fidelity, raw data for an unlimited amount of time, so that whenever there's a shift in threat intelligence, we go back in time to discover the previously unknown. Then we combine that with an immersive user experience that is about deeply dipping people into the sea of information that this represents. It is one thing to have a system that uses it for automated detection, but it's another thing to have the same system be able to make it easily accessible to the person who's going to ask brand new questions, questions that nobody knew how to look for before, or they're chasing something that's not triggering alarms anywhere. Our data set is as good as what it doesn't know as it is at what it does know due to that high fidelity nature of the system. And so the hunters of the future, we have high-speed tools around petabytes of data. We were able to pull all that together, make it super fast, allow you to pivot and dig and filter and sort through all of that, looking for the things that are top of mind inside of your organization. This has never been done before. Nobody has access to this, and our bringing this to the market has a big impact on our ability to ask these questions at all. And so forensics has a brand new life inside of ProtectWise.
Thank you. Excellent. Any questions? That's it. We're done. No, I'm just kidding. How do you follow that up? Excellent. So Anthony's going to kick it off with some slides. Before we get going, we're going to give you a little background on this architecture, because you're going to have access to a complete SaaS model. But we're going to talk a little bit about the deployment. We typically get a lot of those questions, so let's answer those questions, and then we're going to jump into the hands-on lab with you folks. Oh yeah, I'm sorry, I didn't see that. Yes, sir.
Got the catch box right here.
Boom. Coming your way. Sorry.
I said it was agent-based full packet capture to the cloud for unlimited retention.
Yeah. Crazy, huh? We'll talk about it right now.
Talk about that now.
The question
Yeah.
from the
Just wanna make
gentleman
sure I
is
understood.
unlimited retention in the cloud. I know it's wild and ambitious, but we'll jump into it. So we'll go right to your question right now. Let's jump into it. Yes, sir. Coming your way.
How do you address confidentiality of the content?
Great question. We'll also address that. We'll park it right as we go through it. So confidentiality, privacy, sending packets to the cloud, crazy idea. So yeah, absolutely. I love the questions. You guys are framing it up for us. We knew these were coming, so we'll jump into that.
Yeah, absolutely. First off, thanks so much for coming today. We really appreciate dedicating some of your time, valuable time to spend with the great partners here today. hopefully you caught some great glimpses of Denver. That's our base where we're headquartered. Gene Stevens is our co-founder and CTO. Is a great guy, and great to hear his perspective on ProtectWise. So to talk about threat hunting, right, we wanted to start out with just a great quote from one of the guys I've all respected in our industry, Richard Baitlick. The best counter-targeted attacks, one must conduct counter-threat operations. In other words, defenders must actively hunt intruders in their enterprise. And what do we need to actively hunt? It's good data, high-fidelity data, to be able to get to the answers that we're looking to answer and analyze these threats, right? So what we did was created this crazy idea, and what better data than packet data, right? So we developed this technology called the ProtectWise Grid, which is essentially a time machine for your network. And the way that we do this is through these lightweight sensors that Gene mentioned. They're essentially a Linux package that can run on any physical or virtual form factor device, commodity hardware, doesn't matter to us. It hangs off your span, tap, or packet broker infrastructure and collects the packets that are fed to it. They could sit on your egress networks, core, cloud, remote, or even industrial control networks. Really flexible, lightweight deployment. The intention there is to really get you the visibility that you desire and get you the packets and the data. So what we do with that data is we actually stream it in real time to the cloud, right? And for the nationwide guys here, we have multiple deployment options so we can address confidentiality. We have our initial kind of SaaS model. We also have dedicated deployment models, and we can also leverage your existing AWS infrastructure if you want to go down that path. But we're streaming that data, compressing and optimizing as much as possible, deduplicating the packets, et cetera. Typically getting between 70 to 80% optimization on what we're actually sending to ProtectWise. So it's not a one-for-one ratio on what we see on your network and what is actually captured. We're going to be really smart about it and then send it up to the cloud. What we do with that data is actually what is super interesting. So we ingest that data, we retain it for long periods of time, and then we visualize it, which we'll show you here in a minute. The grid, from a detection perspective, right? So not only do we allow you to forensically explore that data by indexing and processing that data and making it available for you, but we're replaying that traffic through a series of different threat classifiers. So we're taking in rich threat intelligence from partners like RiskIQ, Emerging Threats, and others. We're applying behavioral and anomaly detection to that data. We have a fully baked Suricata IDS engine in our platform, heuristics, machine learning. We're doing file analysis on any binaries and documents and whatnot that are transferring over the network, along with application and protocol analysis. And what you get from the output of all this is correlated events, right? We wanted to really collapse the stack, right? You hear from customers all the time that there's stack of different technologies that you have to that look at the same type of data. Well, why not build a platform that can look at that all at once in the cloud and then produce correlated events that you can actually act upon, right? We wanted to really reduce the alert fatigue that you're probably getting today with all these different solutions spitting out all sorts of noise, and wanted to produce true positive events that you can really act upon. And we're going to go through that today and give you some examples. In addition to the detections, we felt integrations was a big part, right? We all have different security technologies within our ecosystem, so we want to be able to leverage that and integrate through RESTful API integrations with partners like RiskIQ is today on the detection and intelligence side. On the endpoint side, Carbon Black, Silence, you name it. We have several different integrations there. SIM, automation and orchestrations with Phantom, you're going to see a bit of that as well. So we're leveraging the integrations, leveraging the ecosystem that you already have in place to be able to provide you the context that you need to be able to answer the questions that you're looking to answer. So integrations is really key for us.
So a couple questions. So you asked, can you do long-term retention? So the answer is yes. So the minute that we moved away from an appliance and hardware-based dependency, and you leverage whether our cloud or your cloud, then the sky's the limit, right? This has been when we look at packet capture for the network, traditionally it's been a luxury for us, right? Because we'd spend maybe a couple $100,000 on software and then 10 million on that EMC array, right? And there goes our security budget. That goes out the door now. Well, you leverage the elasticity and scalability of the cloud. If you leverage, say, AWS, one really interesting model that we have is we'll provide the service per se, but then leverage your S3 buckets to store those packets, right? It's that perfect middle ground to say, hey, you still own the data, you still own the keys, it's all your data. We're just leveraging APIs to access the data and scan it and do that threat analysis. So there's really creative ways to do that. And that, sir, goes to your question on privacy, right? So you've got your standard multi-tenant model, a dedicated instance, and we've got clients, say, like BP, that were traditionally about a year ago very cloud averse, to now saying, well, if I leverage my own cloud, it's my data that I manage, that I use, and ProtectWise we can scan against that. So there's definitely ways. And we can, if you'd like, we can also talk offline further about, how we encrypt the data at rest, how we shard and shatter, all of that as well. Yeah. Yeah, great question. So the gentleman's question is, does it impact performance if you're, with that bottleneck? Actually, I can tell that you've probably lived in the world of IDS and IPS, where we traditionally add more services, right, to a box, and it degrades it. I sold firewalls for years, right? And you say you needed a 1 gig firewall, I'll tell you a 40 gig firewall because you were going to turn everything on. That goes completely out the window. With this system here, each independent system, it's a microservice architecture where it's not appliance dependent, it's not memory and processing power dependent. Each of them can run independently without hindering the other. So no, quite the contrary. By leveraging microservice architecture, we can actually return extremely fast queries and search the data way faster than anything. So little insight, we push Cassandra and Solar up in the cloud to its absolute limits for that. So yeah, great question. I hope that answers. Sorry to veer off, but wanted to get those questions answered. And here's a shirt for you, sir. Coming your way. All right, excellent. Let's jump into the lab.
Yeah, absolutely. So let's do some hunting. So you will receive an email with this information. There's a website, a Google site that we created that has the exercises that we're going to be walking through. We're going to walk through one exercise due to limited time today, and then you can walk through the separate exercises on your own. You also receive an email from our peer Noah Borstad, so look for that name in your inbox. It'll include some credentials to log into the visualizer, which we're going to jump into now. And the URL is located here as well, so visualizer.protectwise.com. Again, you'll receive this information in an email shortly this afternoon.
Excellent. I'm ready to go, sir.
Ready to go. Cool.
Yeah,
So let's get out of here. All right, let's go to 3.
So I'm going to act as the analyst. I'm going to act as you for exercise number 1. And Anthony will also act as you on the UI. So we're going to walk through the exercise here. I'll show you what it looks like. We'll read through it, and then Anthony will actually take the action. Some of you are wondering about this crazy UI, if it reminds you of something. Yes, our head designer is the same guy that did all the CGI work for Tron, Oblivion, Terminator Genesis. It's really cool. It's actually layered with a Unity gaming engine. So you think this is cool when we come out with the VR? Man, it's a whole new level. So yeah, if you're wondering, a little background, I saw some people kind of like getting enthralled. Yes, sir. Yeah, it's right there.
Go to.
Excellent. So first exercise, here we go.
So visualizer.protectwise.com. However, you'll need credentials to log into that, and you're going to receive an email with that information here shortly.
So can you change it to the 2 screens?
Yep. Go back to
All right, excellent. So exercise, so this is the Google site that you'll hit. You'll enter at home here. This will be your home page. And then there's going to be exercise 1 and exercise 2. We're going to walk you through exercise 1, and at your leisure, you can go through exercise 2. You will have access to this site for the next 48 hours. If your interest is peaked after that, give us a call. We can extend it or provide you a free trial as well. So quick one here. So you're at lunch break at the office. and one of the users in the finance department mentioned they think they may have been phished. It's probably not the word they used, but I think I got something funky, right? The problem is they can't remember when or if it was really phishing, so this is probably, they've got a guilt trip going on here. Our objective in this exercise is to find and investigate this possible phishing activity in the ProtectWise visualizer. We'll also want to scope out the potential incident to ensure we understand the complete impact of the activity on your organization's network. Remember, one key point about this, we do have full fidelity PCAPs. So don't hesitate to download and open a few in Wireshark. Once you get the hang of the UI, you'll get the hang of the general analyst workflow. Probably takes typically 2 to 5 minutes. Don't be surprised if it takes a little bit longer, but I see we've got a lot of smart people in the room. That's, we're going to definitely make it easy for you guys. So first thing, we got the phishing attack. So let's prep one, navigate to the kill box, and select the events on the left. Right?
Yeah, so we have the visualizer UI here on the left side of the screen. I'm going to just walk you through some key tabs and key areas of it so you kind of get oriented with the interface. So when you first log in, you're going to get presented with our heads-up display. The intent of this is to provide you kind of situational awareness into your environment, from sensors that are deployed throughout various network segments to protocols in real time that we're capturing and seeing on those segments, active connections that are being established across the globe so you can quickly spot any type of interesting, suspicious types of connections to parts of the world that you may not do business with. And then on the right of that connection graph, we have the attack spiral. And what you're going to see is essentially, and look at that, I just pushed out a new version. I'm going to go ahead and reload that. That's not scripted. We had the attack spiral. So when we talked about those detection engines earlier in that slide, we have a rich set of intelligence that we're ingesting into the platform and mapping to the 7 stages of the cyber kill chain. And the reason for it is we want to be able to answer questions of what type of threat am I facing, what severity, what kill chain stage is this at, and is this something that I need to respond to immediately or not? So you'll see those events and observations pop up here on this spiral, and the intent is to quickly spot those and understand the stages that they're in. On the right, we have the events. And there's different views to look at this. We're going to jump into the event section in a second. The kill box is essentially your forensic workbench. This is where those actionable events are served up. Think of this as kind of your Gmail priority inbox. You have the important stuff at the top that you need to look through that's gone through kind of that sanitization check. And then you've got all of the raw data or the observations that support those events under this observation tab. Most customers focus on the events themselves, but you can also pivot to the observation view if you want to use those observations as hunting triggers to kind of further explore the data in the haystack. The Explorer tab here at the top is essentially your free-form search and query interface. So all of that packet data is indexed and processed and made available for you to search. We have several different metadata attributes that are available for you to search off of, and we're going to show you some examples of that in this hunting exercise. So when you're looking at this, the default view is observations, so that's all that indexed either thready observations, stuff that we've detected using those engines, or metadata that we're stripping out of the packets and making available for you to search. Net flows, and this is a key thing here, if you see up at the top there, net flows is the raw data, right? So essentially just all that net flow packet data. So you can pivot between the two views and search based on that. Reporting, kind of standard reporting, executive summary types of reports that can be helpful for identifying your security posture. And then lastly, our Intel tab and Intel dashboard. So we are open kimono when it comes to the intelligence that we're using to detect things. We're currently exposing 3 types of Intel IDS payload rules, so all of the Suricata rules that either our team has written in-house or that we're ingesting from partners of ours. URL and URI indicators are compromised, and domain are 3 indicators today, or excuse me, 2 indicators that we're exposing. We're working on exposing other indicators that are being used, however, they're just not exposing a public UI today. The intent of this is, one, to show you what we're using, so you can, one, build confidence, right? How do we detect this? How strong of a rule is it, et cetera? And not only that, bring in your own, right? You guys are consuming intel from a variety of different sources. Bring that in and use ProtectWise to detect suspicious activity using packets with that intelligence. So with that, I'm going to jump into the first exercise.
So we're going to navigate to the kill box and select the events. And you're going to see there's a new on the left there. And we're going to select the event that mentions data theft. That's always a fun one, right?
Absolutely.
Select the event that mentions data theft, kill chain progression, delivery to data theft on host. So quick tip here, we're going to get an idea of what's going on with this event. Let's use these various details in the ProtectWise kill box to add context to the event. One thing that I'll mention here, this looks typically, this is a lot of events here. On average, just so you guys understand, we take this concept of denoising pretty seriously. On average, most of our busiest customers' environments are probably only seeing about 2 to 3 events per day. So just to kind of give you an idea of we kind of want to go the opposite direction of what IDS has, where IDS has traditionally failed us and just killed our inbox to the point of really doing that correlation. So now we've got a correlated event. So if I want to get this idea, so my first question is going to be, on this event, what networking protocols do the observations in this event primarily consist of, right? So I'm the analyst. It's probably the first thing I want to know, what's this event consist of here from a protocol standpoint?
Can everyone see kind of the UI? I know it's a bit small, but hopefully you can see kind of what the event consists of. I'll highlight some key areas of this event. So kill chain progression, delivery to data theft. That's the title for the event. We show you the IP address, the internal host in this case that is involved. We highlight the number of observations that have been correlated, in this case 16 observation. We show you the geolocation of those connections in this geo map. We have the start and end time of when those events started and ended, and when our threat engine actually observed it. In this case, it was observed in real time. And then we have a forensic timeline of all of those observations, as you can see here across the top. So 16 observations, let's take a look at them. So the first question is, what protocols did this consist of? So we see DNS. So this started with a DNS request to...
Is yours for now? We can toggle back and forth.
It's screen 2, yeah.
We'll just use yours for now, and then we'll toggle back and forth.
Sure. So we see an initial DNS request go out to Google's public DNS server, 8.8.8.8, and we see the domain acdistributors.ca. Down below that, we see some HTTP requests and several different observations related to that. We'll talk a little bit about the types of observations in just a second. Some more HTTP. Looks like it continues, additional DNS request, and then HTTP. So this, to answer this question, going back to that, the networking protocols is HTTP and DNS.
Excellent. So what is real important, what is the threat score of the possible successful generic phish observation in the event?
Yep. So what we saw here is this internal host connected to 2 different external hosts, right? The first one was the Google public DNS server, and the second one was the actual phishing site that was hosted at 216.113.184.65. If we scroll down through these different observations, the final observation in this event is a payload trigger, or a payload detection in this case. And we have a rule that detected a successful generic phish. We see the score related to that specific observation at 48. So pretty high confidence. So the answer to that question is 48. So that's a medium severity trigger in this case.
Bingo. Perfect. So what detection types created this event? All observation types. So I want to know what were all of the types that package this into one correlated event.
Perfect. So we talked earlier in that slide about the different detection engines that we have available to us. So we have the blacklisting, reputational-based detection engines that's pulling in intelligence from partners like RiskIQ and others. So we see here a malicious domain. So we knew this was a malicious domain based on the intel. It was a low severity, low score associated to that, but we tracked that. We also saw that there was a malicious URL based on our URL reputation observation here. So we have the actual URL associated to that. We scroll down, we see several more DNS reputation observations, and then finally, when we inspected the payload related to this event, we've got 2 payload observations. So the answer is DNS rep, URL rep, and then payload, IDS signature.
So, little quick pause here. I think one of the things that you'll see here is the idea of, oftentimes when we sat in your chair, what we realized that you folks spend quite a bit of time on artifact collection, right? Most of the time, incident response, or we equate threat hunting to artifact collection. The reality of it is that's just one piece of the equation. Oftentimes, we don't even get to the true threat hunting piece. So as Anthony's walking you through the UI, Gene mentioned it earlier, how you interact with the UI. We want to really pivot away from bar graphs and line charts that are inactionable to give you a narrative of the attack in a simple format to view. So we're going to go ahead and go to number 4 here. So I got DNS, payload, and URL rep. So my next question, and this is the power of packets here, right? Let's click on the view stream on the last flow in the event, and I want to know what HTTP request method was used, right? So now I'm digging into this event.
Yep. Cool. So we're going to take a look first. So we see this initial DNS request, and because we have the packets, we could quickly pull out the stream view, see the actual recursive query that was made from the internal host, along with the response from the public DNS server in this case. If we wanted to get a little bit more intel on the actual domain in this case, we can pull out the intel card related to that domain. And in this case, we're enriching the data with passive total. So we have the integration embedded within the UI. You see the IP addresses that have resolved to this domain, when they were first seen, when they were last seen, the amount of records. We wanted to pivot to RiskIQ. It's just a quick click on that link, and if you have the community edition of their account or an enterprise version, you're able to quickly analyze the data that you were just going through in the hunting exercise with RiskIQ. So we have those packets available again for the HTTP request. So we see the initial GET request to that domain, including the oth.html page itself. We see a 200 OK response, including the DOM. And then interesting piece of information here is there's a refer to another site and a PHP page, PHP site included in that. So we're going to go down and actually look at. Sorry.
What's my answer here?
The final observation.
No.
I just provided
what's
some
my
additional
answer? My
concept.
click view here. What was what HTTP request method was used?
Post.
Post. Perfect.
Yeah.
Man.
Yeah. So
All right. Perfect. So next 2 questions, Anthony, is what was the email sent in this request, and what was the password sent in this request? So this is a bit of a leading question, right? Oftentimes, as analysts, we're doing a lot of inferring. We think we know what happened, but the reality of it is packets don't lie. So if we've got the packet data, we can actually come back with the true analysis of what was sent out. So I'm going to go ahead and pivot over to Anthony now. So Anthony, I'm going to need the email sent and the password sent in this request.
you got it.
All right, so I'm going to go UR2.
So in that final set of observations, that's when we actually confirmed there was a successful fish, right? Again, pull out the stream view by clicking that stream view icon. We see the post from the internal host, the header information, and then the actual post body containing the email address and password. So the answer is kevin.g@gmail.com.
Oops, I'll go back and show yours.
Kevin.g@gmail.com, and his password is "this is a good password, LOL." So I'm sure we all have those types of passwords, don't we?
So perfect. So I've got that in there. So now I'm going to close the stream viewer, and I want to locate. So the other question that immediately surfaces is, well, how long did this take to unfold? You know, was it a second? Was it 30? Was it a day? Was it 15 days? So that's probably going to be part of my investigation. I want to know that exact timeline, Anthony.
Well, so we make that, we present that information to you and make that real easy, right? So we see that timeline, that forensic timeline of when the event started and when it ended and the duration of time associated with that. So in this case, it's 30 seconds.
So at this point, we know credentials were sent over HTTP unencrypted to a suspicious domain shortly after the user navigated to it. It's very suspicious, but not confirmation of a phish. Next, let's see if we can confirm this to be a true positive phishing page. So we're going to go ahead and pivot to the Intel page.
Yeah, probably.
Oh, go ahead.
We'll do both.
Yep. We're going to go ahead and click. So we're going to go ahead and pivot into the. By the way, we got like 3 minutes left, right? Okay, perfect.
Okay.
Yep.
Cool.
We're going to click the 3 dots on the right side of the possible successful generic phish observation. Then click on the View Intel rule, and this will pivot you into the Suricata IDS rule, which triggered on this flow. You're not looking at the Intel tab. On the far right of this new window, you can see the rule logic, which caused the flow to trigger. Some basic logic to note. So you look at the flow bits there and the E.T. This means that this rule will fire only if the ET.generic phish variable has been set to a previous signature. You'll see the content piece. That means this flow should have an HTTP 302 redirect code in the post response. You see the other content piece, and this means that the location of the redirect will start with HTTP. That's pretty sketchy. There's a lot of other logic to this rule, but we'll ignore it for now. So number 8.
Cool.
So we're going to click back on your browser to navigate back to the event and kill box. We're going to click the view stream button again on the possible successful generic phish observation. What was the 302 redirect location the user would land on after sending their credentials? This is found in the blue response back from the server, added brackets for safety.
So we see that right there. So we see the initial post from the internal host, and then the 302 redirect to https docs.google.com. Obviously, that's really sketchy right there and a poor phishing attempt in general.
All right, perfect. We'll do 2 more questions, and then our time's up. So there's a whole set here, as you guys can see. So, but we'll end it here in a couple more. The stream also shows the referring page, which is this request came from. What is the requested source and path?
So we've got the refer information included in that initial post request here. You see go into acdistributors.ca, drct, oth.html. Something highlighted in there. So that is the referring page and something we want to look further into.
All right, perfect. Number 10, now let's find the stream for the oth.html. This may lead us to some more context. Starting from the top of the event, open each stream to find the GET request for oth.html. From the top, which stream was it? First, second, fourth, or sixth?
Go back.
2.
2. All right, so we saw that initial DNS request, so that's the first set of observations. We got that here. And then the second one here is the HTTP. Let's take a look at that. So we see a GET request for that specific HTML page in the second set of observations. So the answer is second.
So let's do a quick Google search for that phishing landing page, AC distributors, and look at the results from the URL query and/or URL scan websites. Is this a true positive?
So I'm going to take this malicious URL here from that observation and actually copy it to my clipboard. I'm going to go to Google. Just do a quick, yeah.
Question mark.
Okay, that's good to know. So let's take a look at URL scans results. We see some additional information on it, including a screenshot sign in with email, right? So that's
It's a true
obviously,
positive and a
yeah.
very generic poor
Yeah.
phishing attempt.
Yep.
And lastly, we'll end it with this. We're going to pivot into the Explorer from the phishing page's public IP address. And the other question, finally, now as we're doing true hunting, you might have owned this individual. Who else could possibly, how many other hosts on the network talk to this IP address?
So from that event, you're able to pivot to the Explorer interface, and what that's going to do is going to build a relative query to the time frame that the event was detected. So in this case, we took that indicator, pivoted and searched the haystack, and we see that several observations were recorded in addition to just that one event. So it looks like several other people within the organization actually went to this site, but only one posted. And we can verify that by adding an additional attribute to the search. So we're going to search by HTTP method and look for any post requests. And I'm going to do a search on that. And in just a second, we'll pull back any results related to that query. And as I said, we saw one HTTP request, post request going to this specific IP address in this case. So the answer is one host, which caused the event. So,
Perfect.
Yep.
So that concludes exercise number 1 here. What was the answer for this last one?
so the host reviewed in the event was the only one that successfully got phished. The other 6, like I said, went to that IP address or that URL, but did not actually post credentials. And that's really the power of the packets there, right? So.
And with that, on that note, we ended. So that's exercise 1. Exercise 2 is going to be, you guys will all have access to it before lunch, and you can navigate at your leisure. We're around to answer any questions. Thank you, RiskIQ. Thank you, guys. I hope you enjoyed it. We'll be around. Thank you.
Cool.
Thank you, guys. All right, so we are a little bit behind, but let's go ahead and break. We had 15 minutes. We had 15 minutes scheduled for break, but again, there's restrooms on all 3 floors. So,
Questions, so we can talk and discuss different ways of doing things.
Yeah.
that mic is live too, so don't say anything bad about Benjamin
Not yet.
as you're passing it around.
Got it. Duly noted.
All right, as we're getting settled back in, we're going to start handing out the survey. So feel free to, fill that out. If there's some downtime, you got some extra time, or you'll just have it handy for the end there.
Are you planning to show your...
When you get that back, there's a little token tracker thing.
Yeah, it's a little
handing out.
type of tracker that with your phone you can track something like a tile, but it's not a tile, it's one with a
Yeah, it's like a
removable
tile.
battery.
Yeah, okay.
It's like
cool.
a tile.
It works really well when you lose your keys in your bag at the airport. You need a car. You hit the button, sure, you find the keys.
Awesome. So we'll just have those at the end when we're done. We've got some extra time, so we might flow through some extra exercises as time allows. But thank you all for staying through. And so what we're going to do now is put everything together end to end. So all 4 of us are going to be participating in these next few exercises, walking through how something is detected inside of one platform, pivot into another, roll it all in. But with that, I'll hand it over to the team.
So just go in here, right?
Hey everyone, so as threat investigators, we only usually see the attack once it's happened. And we never see, what the threat actor does. So what I did was I put together a little video that goes through a tool called GoPhish, and this is a tool that's used by pen testers to create phishing sites very easily, and then to use that to phish like organizations to see how well they're doing with security. So you can find this at GoPhish, and it's free. So what we're going to do is talk about a spear phishing attack, which is very targeted. It's very hard for a lot of organizations to be able to find these because they're constantly changing. They're spun up and spun down. So the first step with these attacks, they have to determine what the ultimate goal of the attack is going to be. In this case, they want to get credentials to my account. So they're trying to target me to get into my Fortinet account. Okay? So here's the tool, and this is actually how long it takes. Within 5 minutes, it will be all completely done, the whole campaign. So they take email addresses, they load them into the system, and now they find a legitimate email. So in the past, the hacker would go out there and create their own email, and there'd be typographical errors, things like that. But now they can take a real email, and they just come up, and once they have that email, then they know how they're going to deliver it. Then they figure out what they're going to target. So they're going to target my Fortinet account. So I have this account because I use that equipment in my lab. So now they create their email template. So inside of here, they name it. They take the email and they look at the source. They copy the source. They import the email, so they're now going to paste that source in. They're going to change the links to point to whatever campaign they have. So they can use the same email message and it'll automatically change everything for them. Okay, they do the import. Then from here, it's the landing page. So now they're going to create their fake site. So they take the URL of the real site. They name this landing page in the application. They import the site. Okay, and now we're clicking off these things to capture the username and then to capture the passwords. And because this is a tool that pen testers use, it doesn't encrypt the database where the passwords are stored. So that's just giving you that warning. And then we're going to redirect back to the real site. This is what the hackers do. So now they save the page. Okay, now the next one is to start and launch your campaign. And this is like a marketing campaign. It's very easy for them to do. They start a new campaign, and they can have hundreds of these on the same infrastructure. So they go in and they pick the different templates that they used, and the URL that I have, it's in my internal lab, so that's why I didn't want to go out and get the certificate and get a domain name. And then I get my addresses and how I'm going to send them, and I launch my campaign. Now I'm done. Now I just sit back and wait. So now you're going to be able to see when it was created, what's happening. So right now, it's sending. And this is all real time, how long it takes. So now, down below, you can see the message was sent. Okay? So now I'm in my email. I'm going to go and click on the email. And here's the message. And I'm going to say, okay, I'm going to register. So now I'm in. I come in. I'm going to log in with my credentials now. Now, if you notice, the IP address is different up above. And if I would have spoofed it or created a typo squatted domain, you wouldn't be able to tell. So now I'm going to log in. But it didn't take it that first click, so I'm clicking the second time. Okay. Here's the URL. I clicked once, I clicked the second time. Now I'm in the real site, and I'm logged in. So I don't really know that anything happened. Okay? So now I can see inside the tool that when it was created, the email was sent, when I opened it, if I clicked on the link, and if my credentials were put into the system. Very simple. Now the person can come back in and just click on that replay and log in as me. So now they're logged in. And then I can even view the credentials and then have them to do whatever I want with them, try them on different sites, for example. So this is what you're up against. And they can go through and copy and paste and do many, many different campaigns on the same infrastructure without any effort whatsoever. And because they're using real email messages, you don't really know if this is fake or not. You have to pay attention to the URL and all that information in there. And when you click on the submit, sometimes it didn't take it. You click a second time, not even thinking, and then you look, oh yeah, I'm in the site, everything's good. And you don't know your credentials were stolen. So this is what we have to protect ourselves against. So what we're going to do is go through a scenario that that uses this as like the baseline. Okay?
Cool. All right.
You're on
I think I'm 2.
display.
Yeah.
You're 2? No, I'm 2. There you go.
All right. Great. Thanks, Benjamin. So we, like Benjamin said, we recreated this for this specific hunting exercise. We used GoFish to send out an email, as you see here. So this is a valid email, looks exactly like what USPS, U.S. Postal Service, would send out, contained the link. The link was clicked on, and credentials were phished. So what do you do from there, right? I'd be curious, actually open up for any questions. So if someone gets notified either through your typical support links or channels, what would you do if you thought that someone within your organization was phished? Any feedback, or proxy logs? Okay, cool.
Do you have like different groups? So like if you find out, hey, that there's a bad address, do you have to contact anybody? Do you have to like go through different groups, or how does it work in your organization? Let's say that there's a bad site, a bad domain, a bad IP, and now you want to block it. So you want to keep traffic from going there. So how many groups do you need to talk to be able to do that? Just one group? So let's say it's both an IP and a domain you want to block. Okay, and then generally how long does it take you to get a response or get them to make a change if you see something? An hour-ish, and it's 2 different groups, so it could be hour to hour and a half because depending on which group when they start. Okay, and then once you block that, what else do you do? When someone gets a fish, do you have to do anything on the machines or do anything? So let me ask you a question. So let's say that this went out to your email, your company. Some people are inside, so they're going through your proxy. Some people are at home or on the road. How can you tell if they did that? OpenDNS. So you're looking at OpenDNS to see. Okay, good. Okay.
Cool. Awesome. Thanks for the feedback. Cool. So we've got the email. Assuming now for this exercise, someone clicked on the link and actually posted their credentials. Now we're going to move on to the detection and response side of this. So because we're using ProtectWise, we're monitoring and capturing the packets as we described earlier. We triggered an event, right? We triggered an event based on the fact that someone clicked on the email, clicked on the link, I should say, and actually posted their credentials. So as you can see within this email notification, we have some artifacts. Let me go ahead and zoom that in a little bit. That are helpful. So right off the bat, we see the message related to the event of probable data theft, right? And it's on this specific internal host. It's a malicious flow. The threat score is pretty high, so it's a 60, medium severity event. The kill chain stage is data theft, where we see when it started, when it ended. In this case, this was a real-time detection. So as we captured the packets, we ran it through the detection engine and detected it in real time. And then we include the link to the actual event within ProtectWise to investigate this, which we'll go into in just a second. And some additional artifacts. So the actual URL that was identified in the event, the source and destination IP address. So right off the bat, you've got some really good artifacts that you can use to analyze this event.
So can I ask you a quick question? So when the person went out to that site, as soon as that happened, this email would have been generated, right?
Correct.
And then you would have got this alert, and this would have been your alert in your inbox or on your
Exactly.
phone. Okay.
Exactly. Yeah. So this was an alert that just came from our technology. So we have a variety of different ways to send out alerts, either through email, syslog, output into a file if you want to ingest that in your Splunk instances and so forth. So we're going to talk about how Phantom can be integrated into that story. So, from here, we're going to pivot into ProtectWise, into the kill box we were talking earlier.
So that's by clicking on the link, you would have been taken right in.
Exactly.
Okay.
So you click on that link and you go right into the visualizer UI. So you see that event and the narrative of what actually took place. So again, probable data theft on this specific host, when it started, when it ended, and when it was observed. Right off the bat, one thing that should jump out at you here is the location of the host, the external host in this case, right? So we saw earlier was a U.S. Postal Service. Why is this site being hosted in India, right? That should just be a glaring place. So just starting there, we see 3 connections to this IP address, and here are the actual observations related to that. So we have the internal host, the first observation being the malicious URL. So we, in this case, had, again, some intelligence that we ingested to identify that this is a known bad site. And then we confirm by inspecting the actual page itself using a IDS signature that this was a U.S. Postal Service landing page. As you can see here, we can pull out the packets. As an analyst, you want to look at that information and see the GET requests, all the HTTP requests related to this flow. So we see that initial GET request to that HTML page. And notice the host involved with this. So this is jsb.ac.in. So we'll go actually browse to this. This is a valid school in India. It's a school of business, and from what I understand,
one of our director of marketing actually went to the school, and this is an actual live fish that's on right now on the site. So we're going to investigate it with Passive Total in a little bit.
So we see the GET requests, the response, including the DOM here, and then down below, shortly after the user visited the site, we saw clear text credentials in the post body. Again, inspecting the packets related to that observation, we see the post, we see the host that it's going to, again, that jsb.ac.in, and then the body including the email address and password, so fake email at gmail.com, great password. And then the redirect, in this case, going to mail.lawbrus.com, etc. So we see the phishing attempt. We saw credentials posted in the clear. We want to learn a little bit more about this bad actor and the infrastructure. So from here, we can pivot to the Intel card and pull out the DNS Intel. So we're, again, enriching the information indicator in this case with Passive Total information. And right at the top, we see that domain of interest, right, that jsb.ac.in, in addition to several other domain records that resolve to this one IP address. We're going to dive a little further into this one domain. Again, pulling down the DNS Intel for this domain, all of the IP addresses associated with it, when it was first seen and when it was last seen. And we're going to pivot to Passive Total at this point to further investigate it. I'm going to hand it off to Benjamin to explain.
So everybody, if you can, go into Passive Total and search for jsb.ac.in. Go ahead and do that. Let me show of hands when you're done. Okay? And I'm going to do some question and answer type thing to go through this so we can do a real investigation, because this is a real site. This is live. So this is an active fish. So I want to get some feedback from you. How do you tell if it's an active fish looking at this data? Okay? So if we take a look at the top bar, that's the heat map. That's 6 months worth of time. Okay, I see only one number in there. So that means the same IP address has been used there. So it hasn't changed in 6 months. Now, if I look at the time bar, it goes back all the way, and if I look at the upper left-hand corner, it's September 1st, 2009, the very top. okay? So that tells me that, hey, this has been around for a long time. And if I look, I can see all the years worth of data there. So I'm going, okay, this looks like a legitimate site, and it is. It's a legitimate school. So if we take a look at the WHOIS data, I'm just going to click on the WHOIS data. Let's see if it's private or not. So if we take a look here, it's Janssen School of Business. I see the admin, the tech. I even get the telephone numbers. So this is who I would contact to say, hey, your site is hosting fish. You need to take it down. You need to stop this. Okay? I could pick up the phone and call them. Okay? So the next tab that we want to take a look at, subdomains. You're going to look at subdomains, okay? Nothing special here, nothing out of the ordinary. So how do we say that there's fish? So remember we talked about crawling, how we crawl the internet, and our crawl data has certain aspects that we understand the relationships between websites. So we pull in that full document object model, and if you go out to host pairs, I'm going to expand this out to show 100 items, and I'm just going to scroll down a little bit. So if we take a look at this list right here, you'll notice that over here we see child or parent and redirects or how it's working. So when that page is being rendered on the device, we know what's being sucked in and what's going out. So if it's coming into that website, that's a child coming in. A parent, you're sending stuff out. So we can understand the relationship between how the websites are interrelated to this website. So if we take a look, the very top one, reg.usps.com, that's a child because they're sucking the real website into this fake site in India. Okay? So they're bringing that data across. And if we look down, let's see if there's anybody else here. Oh, USAA is in here as well. So there's other people that are being affected by this. So there's quite a few. So from this point, the only way that you can tell that there's a fish is to say, okay, I can look at this and I can see that it's going into a site in India, USPS, USAA. That doesn't make sense, but that's what you can do in this product. Now, we can also take a look at the enterprise product. The enterprise product, let's say that I was USPS. Now, you have to remember, all the data that we collect is public information. Nothing that we have is private. Nothing's from inside. It's only from externally facing views of information that we're seeing, just like anybody would see on the internet. So I'll show this real quick.
Okay.
Okay. Okay, hold on one second.
There you go.
Okay. So I'm in our enterprise product. And this is information that would be like if I was USPS. So this is, we went out, we've discovered all the devices on the internet, and we've carved out what belongs to USPS through WHOIS records, through DNS, different aspects of information to isolate that digital footprint, all the things that belong to an organization. And because we understand what belongs to the organization, as we're crawling the internet, like Steve had mentioned earlier, if we see something that appears to be USPS, but it's not, it's not part of their infrastructure, then that's a red flag. And in this particular case, here's the fish. So if I take a look at this, it's actually showing me a picture of the website in question that we found. And RiskIQ has a patent called the min-hash algorithm. And what that means is, as we go through and we're scanning the internet, we're hashing the images, we're hashing the pages, all that content, and we're comparing it to every other site in the world. And when we do that, we can get a score, and we're able to quickly see, hey, we crawled these pages, and these pages appear to be from the USPS, but they're not. It's on this other site. So we're able to find that immediately through machine learning. And because we have all that crawl data, I can actually come here and look at the response. the DOM, the files that were being pulled, the cookies, the links. This is all available to the enterprise people. And then from here, you can even do an enforcement. So I can do an enforcement, and when I do the enforcement, I can bring up a template, and when I bring up the template, it already pulls all the information on who to contact. And so as soon as we submit that, we also notify Google and Microsoft. So they pull our blacklist every 10 to 15 minutes. So the minute a customer notifies our system, hey, this is domain infringement or a phish against us, for example, all of the world's browsers, 95% of the world's browsers will not go to that site anymore. So I'm not only protecting my internal users, but I'm protecting everybody in the world just from doing my investigation and saying, yes, I'm confirming this. Boom, it's taken care of. And then it takes about a day to 4 days for the sites to actually come down. And then through managed services that we have, we'll actually even follow up and call and verify and make sure it's down. And the system will automatically look at it and tell you if it's up or down. So that's the way that you can understand completely and definitively that, hey, this is really a phish because we grabbed that other data. Now, the hunting tool that we have, Passive Total, that gives you a certain aspect, but it doesn't give you these other bells and whistles that the enterprise tool does. But the data's there, but some of the pictures aren't. So the only other way that you could investigate is to actually come in and bring up the site and look at the site and say, hey, yeah, it really is bad. And so I'll turn it back to, are we going to go with Flashpoint next or Phantom?
We're going to go with Phantom.
Okay.
Yeah. Tie in the Phantom piece. So earlier, the gentleman said, you look into your proxy logs, right, and try to identify. So we're going to tie that in. One quick feature that I will demonstrate here within ProtectWise and transition into Phantom. So we have integration with tools like Palo Alto Networks. We could quickly pivot to the firewall logs in this case related to the timestamp of when we saw this event. And we can pull the traffic and threat logs on demand and view them within the ProtectWise console to identify whether or not the firewall in this case allowed those connections through. And in this case, we did see the connection allowed. So now we want to remediate, right? We want to respond to this and try to improve our posture and prevent this from happening again. So passing it on to Phantom. We have the ability to ingest this data and these artifacts into Phantom and then actually remediate and enrich the data. So passing on to Rick to talk to us.
Sorry, it's my test. All right, so all of the things that you saw accomplished just now with all these great tools, you could speed that up, do this in 40 seconds, I think is our going time for it. Obviously, there's a lot of other collection you can add into it and things that you would stop to ask before you do, like blocking an IP address or a URL. But I'll just kind of cover how that use case looks in Phantom automated. So on the apps page where I'm at now, these are the integrations we've connected in the lab. So the geolocate, MaxMind, OpenDNS we're using to block the name, and then Palo Alto we're blocking the URL and the IP. You mentioned looking at logs. We can add your SEM in here and go look and see in the last 2 weeks has anybody gone to that website and did the proxy allow it. We can block it on the proxy too. So there's other things that you can get creative with. So we'll go through the case that we've got so far built here. Do the playbook.
You need to ingest. Oh, the playbook, yeah.
Yeah, let me go there. So this is the playbook for this use case. And so ideally, you've got one process that covers this type of an event, a spearfish or a fish of any kind, or an alert from, in this case, ProtectWise, comes in, and the artifacts, depending on what's available, usually in this case, we've got a specific email format. We're getting the same thing every time. So we know there's a source IP, a destination IP, and a URL we want to check out. So we're doing reputation checks on those, obviously going out to Passive Total for those. We're doing a hunt on the IP, the destination, to see what other conversations happened in our network going out to that IP. And then we also get from ProtectWise the PCAP file of those conversations. There's more you could do here, like handing that off to another playbook to go check out the endpoint, scan it, maybe take it off the network if necessary. But then on the top string of events here, the domain, if it comes back bad, known bad, then we're going to go ahead and block it, the URL as well, and the IP if needed. So those are based on just one condition here, obviously, but you can add multiples, so you could get a reputation from 3 or 4 sources if you want, and then make your decision based on that. You can also stop and ask somebody if you really want to do this, put a human element in that case before you actually take something down. And something other customers have done is you've got a whitelist of domains you own and IPs you own. You can put that in here so we don't accidentally block you from yourself. What I'll do now is go in and ingest that email.
The top there.
Oh, it's on the top. Thank you. Yep. All right, so to do that, I'm going to open up the email app. I think we've got it set for a 10-minute poll. I don't think it's come in yet, but I'm going to go ahead and just manually tell it to go check the inbox. So if you do this in a polled cycle, obviously you've got 10-minute increments of dead time. What's better is to initiate events from the outside, so when ProtectWise sends that alert, we can also push it straight into Phantom through the RESTful API, so you get more of a real-time response. Okay, so it just read the email, successfully added it. Now I'm going to go look at the events. And so under my sources, I've got the ProtectWise events category that we've set up here for this. And I see now there are 5 artifacts. Let me open this up. It's already kicked off the playbook, and it's mostly done. Right now we're waiting on the block IP and the block URL actions to finish, but everything else is completed already. So we've got our locations, India. We see that the successful block on the Palo Alto, the IP has been blocked. So we get a code back from that device that tells us it's finished. And then some other information, the passive total response. And this is just the quick heads up widget display. There's more detailed information behind the scenes that you can gather and push into another ticketing system, permanently to log this information, everything that's happened. As well as the heads up display gives you a quick overview of these are the actions we took. So you can have the playbook push any data in there you want, but this is the way we've configured it for this use case. So now it's done. That took about less than a minute. So back up here. So if I switch out to the dashboard and take a look, zoom in a little. Yeah, I see that my executions on this one, I've just run out. I've got it clearing out every day, but execute time 40 seconds to perform those actions. Obviously, if you throw things in like searching the SIM logs to see if anybody went there, lookups, sandboxing, that sort of thing will add time to that. But it gives you a quick response to a potential threat based off of the alert. That's it.
Cool. Awesome. So we're going to bring up Eddie from Flashpoint to talk a little bit about how Flashpoint can enrich this type of situation. So. Yep. Give you the mic here.
Cool. So I'd like to apologize first and foremost. While we would ideally like to show you the integration in RiskIQ, it's not quite ready yet. However, I did see a demo of the integration a few days ago, and I think everyone who's existing RiskIQ customers is going to be really impressed with what we've done. So here, this is not working well, me holding this. Real quickly, RiskIQ asked to show an end-to-end demo with Flashpoint data. So while we don't have any specific intelligence related to this particular campaign in terms of obtaining credentials for USPostal.com accounts, we have seen very recent activity within our data sets and within our intelligence that's being targeted towards US Postal as well as other entities. So just real quickly to show you what intelligence we do have very recently attempting to target US Postal and others. I'm sure everyone in the room is very familiar with the well-known Ramnet banking Trojan. Shares a lot of similarities with the old, the very popular Zeus banking Trojan that was around for quite a number of years. I believe the source code for the Zeus builder was leaked back in, I don't know, like 2011, 2012 timeframe, somewhere around there. So Flashpoint has been tracking, as I mentioned in my earlier presentation, a number of popular, what we call commodity or off-the-shelf banking Trojans, ransomware variants, Ramnet being one of those, TrickBot, Drydex, TrickBot being the main successor to the well-known Dyer banking Trojan. I'm sure you're all familiar with that as well. But so basically, our SME team tracks very closely redirects leading user traffic to one of the most popular exploit pack technologies that's available now. It's called RIG. So there's one particular gateway that leads into a RIG landing page that's called the seamless gate. So our analysts monitor traffic that's flowing into the seamless gate very, very closely. You can identify seamless very easily because it has, I believe, 4 or 5 very unique URL parameters in the URL that is contained within the iframe of whatever compromised site is redirecting to that gate. But what we've seen, basically, we pushed out intelligence to our customers in very early January that a new variant of the Ramnet banking Trojan that's being served through RIG was targeting user credentials from a number of different retail as well as technology platforms. So traditionally, obviously, banking Trojan, it's targeting banking credentials from well-known consumer banking sites. However, in January, we saw the addition of additional web injects to grab credentials for other sites. So here is basically from the victim's perspective. So this is a Ramnet infected host. And as you can see here, this is basically a login page that has a web inject to intercept Microsoft credentials. So this is what it looks like from the victim's perspective. But if you look at the source code on the page, you can actually see this blob of JavaScript down at the bottom with several characters encoded in hex. So the top variable there is the URL of the site that it's grabbing the credentials for, because what happens is the victim, when they enter their user credentials in, very similar to what we showed in the last demo, once you click login, it intercepts the credentials and then redirects to the actual page. So that top variable is the actual page to redirect to, and then you can see that other variable SA there. It's a base 64 encoded string. That's the URL. If you decode that, that's the URL where the intercepted credentials are going to be transmitted to. So here you can see that the bottom thing is what builds the request. The send script request is what builds the request, taking the URL and the various URL parameters that's stored in the RiskIQ variable there. So that's what it looks like to the victim. So in addition to providing intelligence to our customers related to, hey, web injects are now available for U.S. Postal as well as others, we also have intelligence related to the attribution aspect of this. So we firmly believe we know the identity of the Ramnet gang who's behind this particular banking Trojan. There's essentially 5 core members of the gang. Just to paraphrase, the expertise of the gang is broken up into these different areas. There's one individual who's an expert in the infrastructure, so he's well known within multiple Russian language forums as a seller of bulletproof hosting services, VPSs, so on and so forth. There's two members of the gang who are very well versed in bank fraud and cash out operations, which is how to monetize access to compromised banking accounts. There's a third member of the team who is the core developer and is also the one that creates the web injects. So the web injects are basically just plug and play like configuration modules that can be loaded within the core Ramnet source code. And as I mentioned, the web inject syntax that I just showed on the previous screen borrows very heavily from the old Zeus source code. And then there's the fifth member of the Ramnet gang is an expert in traffic direction systems, or TDSs, as well, that I think Nationwide was touching on TDS technology in their presentation. So this is one of the individuals. So we've provided intelligence to our customers related to like all known identifications of these individuals, including like surface web social media profiles, so on and so forth. And as you can see here, this is just a small excerpt of the intelligence brief that I mentioned that we did push out to our customers in very early January, and I believe this phishing campaign, from what I saw on the screen, was from around the February timeframe. So we did provide some proactive intelligence to our customers that interception of U.S. postal credentials was something of interest within the underground. So yeah, I mean, there's some other ones out there as well, but yeah. So, thanks.
Yeah, one thing I want to talk about is everyone's talking about the cyber kill chain and trying to stop an attack during different phases of the kill chain. Now, one thing you probably maybe didn't get or something, we want to be able to show you that the cyber kill chain, we focus on different areas. So for example, Flashpoint, they're focusing on finding stuff early in the planning stages while people are talking about doing stuff. And then on the open web, so that's in the deep dark web, and then in the open web, this is where RiskIQ shines. We're looking at the infrastructure, when they're doing the recon, when they're doing the setup to do their attack, and doing the weaponization. That's when we're shining. That's where we're seeing all of those areas. And we're able to stop it in that area before it gets inside of your organization. So once it gets inside, this is where Proofpoint comes in and Phantom and things like that to make these changes to find out where it's in the stack and where they're going to be able to stop it. So all of these tools help you in different phases, early, before it happens, or after it happens, and then trying to remediate changes inside of there. So we want to open this up to questions and make this interactive. So are there any questions from any of the presenters today so far? Or is it, because this was a live site, this was a real active fish that we wanted to go through and say, here's something that's real, it's live, here's how all of our products see this, and how we all can do remediations and fix and block this in different phases. Yes? Oh, can we throw you the box? Perfect.
Okay.
Hey, you can talk into the top and it'll work.
Okay. When it triggered to show that there is a malicious site that the user went to.
Are you talking about through Proofpoint?
No, ProtectWise.
ProtectWise. Okay, ProtectWise. I'm sorry, ProtectWise.
So does it need the user to tell you that already they went to a phishing site, or it's triggered automatically to the system? So, like,
is the question you're asking, how do we know it was a malicious?
yeah, like user need to.
Here's
yeah.
your mic.
User need to inform you.
So I think the question you asked is how do we know it was a malicious URL
No,
site?
if the user need to inform you that they went
No.
to. Okay.
He's asking, did the user need to call you and say, I went to a malicious site? When your rule triggered,
gotcha.
how did
Yeah.
the rule trigger?
So we triggered on a few different things. If you remember from that event,
Yeah, signature or something like that.
correct, yeah. So one, we knew we ingest Intel ProtectWise, I should say, not we specifically, but ProtectWise ingests threat intel from a variety of different sources. And one of those sources provided us the fact that this was a live phishing site. It's a known malicious URL. So we detected on that, and then we also had the IDS engine look at the content within that landing page, and it triggered an IDS rule to say that this is a USPS phishing landing page. So that in itself was interesting, but what actually bubbled it up to an event and alerted the analysts to investigate it was the fact that credentials were posted. We would have not generated an event. And that's just the difference in why I want to kind of emphasize that. We would have not generated an event if credentials were not posted.
So
It would just be an observation.
So it's gonna be post over HTTP, because if it's post over SSL, you'll not see it, right?
Correct. So yeah, in that case, it was posted over HTTP, which in most cases, and I don't know if the team here would agree, from what we've seen, most of the time they're leveraging just HTTP for these types of phishing attacks, not SSL. And maybe actually be open to feedback from the team too.
Yeah, it's now with Google 68 coming out in June, you're going to see a lot more attacks over HTTPS because traffic's going to be blocked from sites that are not HTTPS. So that is going to be a trend that we're going to see because normal people won't be able to go to those sites. It's going to say, hey, it's not secure, don't go there, and it's going to be red.
Mm-hmm.
Okay, so I'll get it. It will trigger even the user. It's not telling me, because sometimes we see users, they post information but they don't tell us, and we just find out from another user who reported the email to us.
Correct.
Okay.
Yeah.
So they have an observation, and then they show that, hey, something really did something bad. So they'll see it as an observation, and it will say, hey, we saw the email came in, person went to the site. That's the observation. But then they go, hey, credential, that's bad. Now you have to take action.
Yeah.
Okay.
Yeah, absolutely. Yeah.
Thanks.
Was there kind of a second question related to SSL? Is
No,
that
it's like, no, it's just
okay?
just letting us know.
Okay, cool. All right, no problem.
How many people are breaking SSL in their networks that you?
Yeah.
I was just genuinely curious.
I do it at my house, so from all my kids. So, yeah.
Yeah. Cool. Any other questions?
Anything else? Okay, so we're going to go and I'm going to show you some of the enterprise stuff, and we're going to make this interactive. And then we will have extra time for extra exercises. So if there's something particular you have a question about, or you want to see, we can even throw it up on the screen and do some searching and search for things. Okay? So one thing I want to do is we ran out of time in the morning to show you digital footprint in the passive total product. So what I like to do is I like to show you that real quick and explain it, and then we'll go into the enterprise product. So did everybody create their account today using your corporate email address or a Google or your own personal email? How many people use their own personal email? Okay. If you use your own personal email, you're not going to see this. If you create one with your corporate address, we've already scanned the entire IP4 space, all the open web, and we created a map of the internet. And so when you create a credential, and you can go back and create one with that promo code we gave you today, we will show you your piece of the internet, all of the externally digital assets that belong to your organization. So I'm logged in with my RiskIQ.com account, and if I take a look at our our domain, if you search for your own domain that you belong to, so not a Google or Hotmail or any of those, you'll get this other one called digital footprint. And inside of here, this is showing your piece of the pie. This is everything that you own that we've seen. It's not been curated. It's all automated to be able to do this. The enterprise product, you can curate it. But this one is just showing you all those pieces. So what's nice about this is I can look at my picture, I can come in here and I can get insights. So I can say, show me everything that has a critical CVE. So if I take a look and I see all these little blue dots, I can actually select one, and when I select that dot, it will bring up more information on the right and show me that. So I can see what ports were here, I can scroll through, I can come and look at a listed view or a table view and see all that information. And I have all this information available. So I can go through and see if something is vulnerable or not. Now remember, we're not going out there and testing for these vulnerabilities. By looking at the open ports, we scan over 114 ports when we go and crawl the internet as well. We're able to look to see what ports are there. So then we look at also the framework, so the web components that are there in the frameworks, and be able to match those together to say, hey, these vulnerabilities exist with this version of software that's running on that box. So then we're able to show you potentially these are some areas that you might want to look at. So this gives you a good way of looking at things that are part of your organization. Maybe it could be an acquisition. You buy something, it's now part of your organization. When we scan it, you see it, you can do something with it. Any questions with this view? And what's nice about this, if I click on the check, it filters for it. If I click on the X, it filters it out. And that's the little toggle here. So I can come down here and say for owned assets, we want to make sure that we're very sure these belong to you. I can check those off. And then I can go in and say, hey, what's blacklisted? Oh, there's one item that's blacklisted. Why does RiskIQ have a blacklisted site? And it's this little blue dot right here. So we scan the top 5 ad networks. So they give us all their ads before they put them out to the public. So when those ads come in and we're ingesting them, we actually play them on this box. And we have crawlers that go out there and interact with those ads, just like a user would. And so we find malware and bad stuff, and then we blacklist it, but it's our own box. So that's why that appears. Okay? So this is a way for you for free, to be able to see your infrastructure and your piece of the internet and all of your externally facing digital assets. But it only shows up if you use your corporate email address. Any questions? And if you want us to take a look at your own footprint, if you have questions, we can talk to you afterwards if you don't want to show anything. Or you can bring up your laptop and plug it in and everybody can see. It's up to you. Okay? So we'll talk to you afterwards. Okay? So what I'm going to do now is I'm going to go into the enterprise product and show you a couple of those things. And I'm going to make this interactive in a couple areas. So when you become an enterprise customer, we have digital footprint and external threats. So digital footprint is like your asset inventory, everything that's out on the internet. But from that, you get an inventory that you can search and you can find things about. So this is our dashboard that's bringing both the external threats and the digital footprint piece together. When you take a look at this, I can immediately look over trends, historical data, how things look, what's happening. And on the right side, I can take a look and see, hey, there's some malware, there's some phish, domain infringement, some issues with SSL certificates. I have all this stuff here. Now, one nice thing about our product is we have these dashboards, and one of them is called Insights. With these insights, these are like saved queries. We have some by default that we give you, but then you can create your own. So if I came in here and I look at test sites, it will show me all the sites that are test sites, but there's one in here I want to look at. Untrusted certificates, servers, site access. At-risk frameworks, site. So let's look at site access. These are login pages. This is everywhere that login pages are in here. So when I select this, I'm seeing everything. But now I can come down here, and I'm going to look where the final URL is not HTTPS. And I can look right here. Here's the login. And this is a website, survey.usp.is.gov. I can select it. I can get more information about it. And if I actually went out there, since this is all internet-facing public information, there's a login. So it's a way for me to go look at my own inventory and make sure that I set up stuff correctly, to look at it and say, hey, we have a login, and it's not behind HTTPS. So all of these insights are here to look at that inventory and slice and dice it, whether you're on the vulnerability side, you're on the pen test side, you're on the operations side, to be able to look at this data and give you insights into your digital footprint that's out on the internet. And it's the way that the outside world looks at you. So just like the way the hacker would look at your organization, to be able to see all this information. This is what we're giving you. Now, inside of here, we also have the ability to do research. So from inside of here, I'm going to go over and let's look at research mobile apps. Show of hands, how many organizations create mobile apps for your own company? Okay? So inside of here, we go out to all of the different mobile app stores. Let me just log in here. I'm going to bring up something real cool to show you. Okay, so currently right now there's 202 app stores, 106 are active, 8 platforms, 10 languages, and there's over 26 million apps out there right now around the world, and you can see where these app stores are. So we're going out there, we're talking to these different app stores. We bring, for all the ones that are not Apple, for Apple, they share their metadata with us, but for Android and things like that, we're actually bringing them down, we'll open them up, we're looking at them. I want to go through and do some queries. So let's look at blacklisted mobile apps. So out of all the apps that we have in here, there's like 840,000 that are on the blacklist. So if you give me a name or a company, I can do a search and we can see what shows up. So you can be brave or yell at your friend's company. So let's do this. So let's do the title contains, give me something. Can someone throw the mic? I can't hear you. It's right behind you. My goal is to have 5 people use the mic this afternoon. Let's see.
Dinsmore.
Can you spell it?
D-I-N-S.
D-I-N-S.
M-O-R-E.
Okay.
.com.
Okay. Nope. No, nothing on the blacklist. So is there somebody, anything else? Let's do Starbucks for right now. Okay, so here's some Starbucks ones. So if we take a look at this one, okay, it shows me a picture of the app. But if you look right here, it's in another language. So if you're going to do research and find these apps that might be all around the world, and you don't know all these languages, we have this cool little thing. It has Google Translate built in. So I can click on it and actually get the translation. So I know what they're saying without having to pick up the phone or do anything. So now I have this information. If I scroll down, all these URLs, when we sandbox it, these are all the URLs that were active. So we look at all the URLs, and you can see everything inside of here. Okay? If I take a look at the versions tell me how many different versions are here, and you can actually download the APK if you want. So we give you access to that. We have the files. We can look at the blacklist, why this is blacklisted. And this one are all the different companies that have identified this as malware and what particular malware is there. And then why it was classified as saying Starbucks, because I searched for the word Starbucks in there. Okay? And then if we go through all of these, you can see different types. So I can even come in and say, let's look for Trojans. So all of these are Trojans. So Black Friday, when they have those apps, Black Friday app, come here, see all the ads in one place, make your life easy. Every year we do an announcement about all the Black Friday ads that are, or the apps that are bad, just to notify people, to warn them. If you're going to be leaving, please make sure you fill out your survey so you get your CPE credits and your tracker if you're going to be going. Any other ones you want me to search? Anything else? U.S. Bank. U.S. Bank.
One word.
All one word? Okay. Let me go back. And this is looking for Trojans, so let me take this off. Nope, nothing for U.S. Bank. Anything else? Be brave. If we find anything, we'll make screenshots and give it to you. So if it is your own company, we'll tell you what we found and where it is so you can take action if you want.
Two hands.
CINNBELL, right? Oh. Sin, C-I-N.
Two hands. Yep, ATI.
TI.
Okay, Bell. Okay, great. It's my first time to Cincinnati, if you couldn't tell. Okay, so nothing on the blacklist. Sure. And then we'll just try Cincinnati and see what shows up. So this is showing up with Cincinnati. Here's one that's Bell decorating. Bell ring. So there's some questionable things out here. Entertainment, school bell. Yeah, Lexi Bell. No, so you're looking good. Yeah. So so if you take a look at like what all the apps that you use in your on your phones, so you might have Box, Dropbox, or something like that. You'll see tons of stuff out here. So it's usually popular apps, but they could be targeting your brand. So a big one that I found that I was surprised with was Coca-Cola and Pepsi. When we did this announcement, CNN contacted us the next week and said, "This is incredible that you found this. Are there any other ones?" And so we went through the top 50 brands, and it was incredible that we found one in Israel that was actually still active and had great reviews. So it was scary. So if we take a look, there's a way to see how many people are using those. Let's see. Share a Coke, Coca-Cola. So let's take a look at this one. So these are all the permissions. So take a look at these permissions. Read call log, read external storage, write to settings, internet, kill background processes, read logs, mount, unmount file system, disable key guard. These are all the permissions that are happening here. So one of the things that we're seeing as well is that sometimes you have your own app for your organization, but somebody takes your app and doesn't do any modifications and puts it out for $1 and says it's the new improved version, and they're not doing anything, but they're just making $1 off your own apps that you're doing internally. We're seeing that. Or they take your app and they change the permissions to give them more permissions on it, and then they release it. So those are some of the other things that we're seeing out in the wild. Any questions? And so what's nice about this is I can translate this. I can see this one is on com.aoi downloader, so I can see where it's located and have all the information necessary to be able to take action and see what's happening. And then if I want to sandbox it and crack it open and look at it, I have access to do that as well. We also do this for social media, so all of your social media accounts for your corporation and your executives, we can monitor and keep track of and see what's happening with those as well. And what's nice is that we're scanning the links that people put on there. So if there is malware associated with it, we find that and we let you know. Okay? So we have some more examples, so we can go through and do some more examples, take questions. How would you like to proceed? Would you like to do another example inside of our product? That we go through and do a quick search? Okay. So let's go into community.riskiq.com. Let's log in. And we're going to do a quick search. Just going to grab my deck. So I want you to search for safetynote.antivirus.com. Okay, so we're going to search for safety note. Safety note.xyz. Sorry about that. Safety note.xyz. Do a search for this. And let's do a discussion on this one. This is a good one because this is something that people will come across all the time. So this is no longer an attack, but it was a good one. So this is one where you would go to a site and they would tell you, we found malware on your computer. Call this number to get it taken off. So from here, how can you investigate this to determine if there's something bad associated with this domain? So where should I go? So right now, it's showing nothing in the time bar, and it was active a long time ago. Okay? What's the tab that I should go look at? Give me a tab. Host pairs. Okay, so there's some stuff with host pairs. Okay? So if I take a look at host pairs, do you see anything strange with these names? Yeah, they're all typo-squatted domains. And with all of these domains, there's something that's strange happening here. So what I'm going to do is before we go here, I'm going to go to the subdomain, antivirus.safetynote.xyz, and I'm going to click on that. So that will search and bring up that subdomain that's associated with safetynote.xyz. And you can see it's been marked as malicious. Now I'm going to look at the host pairs from inside of here. So remember I talked to you about parent-child relationships? So if I'm sending stuff out, that's a parent. So if you notice that track.mcwtg400.com is a parent, and all these other ones are child references, so that means they're coming in. So these were all being redirected to antivirus.safetynote.xyz and then forwarded onto that track.mcwtg.400. So if anybody typed one of these bad, Dropbox.om, WhatsApp.om, Tumblr, United, Toys R Us, WallStreetJournal.om, you're automatically redirected to antivirus.safetynote.xyz and then immediately forwarded to track.mcwtg400.com. So that's how this was working. So you would type one of those, you get to this one domain, you get to the next one, and then that's where it would show up saying you have a virus. So it was harder for you to detect because if you didn't have these host pairs, you're going, hey, that one website, antivirus.safetynote.xyz, it doesn't really have anything, but when you hit it this way, it would redirect you and you wouldn't see it. You wouldn't be able to detect the other one. So this was an active attack that was happening. Any questions with this, with host pairs or any of the other things? Yes? So that's a great question. So one thing I could do is I can come up here and I can copy all this, okay? And I could paste it. I could create a project. So I can take this list of information and I could then do an action with it. I can do it with Phantom. I can do something. Would you like to give some suggestions of how they could do something with this data, the list? Like if they wanted to take this list of information and do something? There you go.
All right. So I think you have a couple options when you're doing an investigation and looking at the data table. Benjamin noted you have the copy button that just copies out a comma-separated version of what you're seeing in any table, and you can paste it to a clipboard. You can paste it into reporting. A lot of people end up starting to put things into projects and then shipping projects over to other devices in their network. I would suggest the best way to integrate our data and what you've done in an investigation is through our API. Everything that we're walking through here today is available via an API. So if you want to start programmatically pulling this data into other systems, that's the best way to go. Copy and pasting is kind of a nice feature that I want as an analyst to share some context with people. Or maybe I have a handful of domains or IPs I want to go and push to a block list right away. That's what that kind of functionality is for. As you start to get into a much more automated scenario, the way we were showing this integration with Phantom, pulling this data into ProtectWise, is it all ends up in the API. And you can get everything that we are seeing here granularly in the API. You can pull all artifacts from a project. You could pull monitors in a time-sliced format. When you ask, apologies, I don't know who asked. When you're asking about bringing this into other systems, does that answer the question? Is there a more specific thought you had in mind?
It was over here.
Okay. Yep. If you are a command line person, there is a command line client for PassiveTotal, pip install PassiveTotal 2, and you can go through and access all of this data in command line form. One of our engineers, Nate, was new to the project, and that was his first job, was to document all undocumented APIs. He hated me after that. And to update our client to include all of the crawling data that we talked about. So it's a really quick way to interact with that data, not in the UI. And if you want to use it as a way to program against, as we update it, you can just update the client. Makes it a little easier to interact with our API instead of programming against the endpoints individually.
Yes. Uh-huh.
There is. The reason behind that is when you look at our historical WHOIS records, that database, there are two separate databases. We have a current WHOIS database that's about approaching 1 billion records right now that's fully indexed. We have a historical WHOIS database that is roughly the same size that we have not indexed at this point. And so when it's grayed out, it just means that it's not a current record. It's not in our current database, and we do not allow a pivot off of it. Doesn't mean you can't go and run a query for some of these things. It just means that it's not indexed at the moment. We're looking to index that data. It's kind of a cost benefit. I have only so many engineering resources to do this. And every time I ask, they're like, well, it may take a month. And I was like, well, let's go do something else. Let's go focus on crawling data. What's more valuable to an analyst? And we've made kind of the determination that while history is very useful, we'd rather put our resources towards some other things in improving crawling and getting additional data in the platform.
Yeah, but you brought up a great point that right here there was no who has record, but if I go back in time as I go through, I can take a look to see how it's changed. So that information is available.
This is also going to start to kind of impact us a little bit, and you'll see this is going to impact the industry in general. With GDPR coming into play in May, privacy laws are going to start to impact possibly some of this data. IANA hasn't given any rulings on whether this will fall under those privacy rules, but there may be scenarios where this data is protected and not publicly available anymore, thereby reducing our ability to collect WHOIS data. And so we're kind of bouncing back and forth with that. GoDaddy tried to get ahead of this a couple weeks ago, where they haven't received any guidance. GoDaddy started to block the amount of information you can get from their public WHOIS lookup. So if you do a command line lookup for a GoDaddy, a domain that's registered using GoDaddy, you'll start to see things are starred out in the data they return, personal information like name, phone number, things like that. We've started negotiating with GoDaddy to get access to that database anyways, but that is an area that's going to start to affect us as an industry. WHOIS is kind of in flux at the moment. If it falls under GDPR, we may have to do some interesting things like start to hash all this data you see uniquely and then allow you to pivot on the hash but not let you see the data. And then it becomes a little confusing. So something as researchers to be aware of. There are some implications to that ruling coming down. That was a tangent. Any other questions?
You see many implementations where they'll take something like email that comes in and then trigger it through Phantom to actually block outbound to that IP address, like through, and then maybe like backtrack through ProtectWise and see if anybody else might have clicked it. Like the user says, "Hey, I got a phishing email." You hit the little report the phishing email. I get it. What can I do with that? Like programmatically to say, okay, I don't want anybody outbound to hit that IP address now, and I want to track through ProtectWise if anybody else hit that did it.
Yeah, I think that's a really common use case that we started with Phantom, and then that's kind of how we're going in the direction with ProtectWise. And a little bit about what we were trying to highlight today was that having that kind of information come into an abuse box, ingesting it from RiskIQ's side, we can go out and parse the URLs, crawl them, give you context around them. But it also kind of tangentially starts to kick off that workflow of, okay, let's block this so that no one else goes to it. And then through a ProtectWise implementation, let's go see who else may have hit that URL, may have received that email, and try to automate that aggregation of how broad is the scope of this issue, as opposed to.
Phantom actually can go out and like hit the checkpoint firewall and say no, it's not IP address.
Correct. So they can basically say, I think you showed an example where they push directly to Palo Alto, but I think they can push to any kind of firewall in your environment and say, if this we see phishing email, these are the IOCs from that email, block those at my devices, and then as analysts you can go back through your other SIM, whether it's ProtectWise or something else, and then say, okay, now let's triage how large scale that was. So if anybody else receives that inbound email, they're being blocked at the proxy or the firewall gateway so that they're not actually hitting the malicious URL. Yes, sir. Yeah, let's do a quick run through.
So we'll
I'm going to look at host pairs.
okay. Let me.
And I think that's a valid scenario, and that's something we're grappling with more as we bring this type of data into the platform. Is it's a lot of information. I dig through it on a daily basis now, and I find it very useful. But I also find it overwhelming because there are scenarios where we're not only bringing in there are malicious correlations that sometimes take place, but there's the preponderance of information is legitimate. Everybody is connected to Facebook and Twitter and LinkedIn and all these kind of social media scenarios right away, and so that's a lot of noise. And you start to add on to that. Just normal websites are now made up of so many different third-party pieces of code or pulling content from so many areas that host pairs can start to get overwhelming. This example, using antivirus.safetynote.xyz, it's a .xyz domain, so there's not too much legitimate going on with it. But what you can see, and what really starts to stick out in host pairs for me, is if you look at the first scene, last scene column, you'll see here, 2016, February 3rd, 2016 through February 3rd, 2016. Single day correlation. When we start to see those types of redirection sequences that are over a very small time frame, those are the things that are interesting. So when I go into, when I look at something in passive total, can you scroll to the top? We have the ability to start sorting things in the platform. Right now, we cap our host pairs at about 2,000 results, just because implementation-wise, to display that to you, there was a limitation on how we engineered the front end of the platform. Right now, we're in the process of redoing that so that I can show you every host pair I've ever seen. That could be 38, that could be 20,000. We're just implementing paging in our platform. But what you really need to do when you're looking at this data is start to filter last scene descending, or sorry, first scene descending. It'll start to show you the things that we've seen today and today only, and start to creep down, whereas the default view starts to show you last scene descending. So it shows the most recent, but sometimes that's not the most interesting. If you've seen something that's just resolving today, that's really where I start my investigation, is that like kind of very fine time frame. And a lot of times when we're showing thousands of host pair correlations, I usually don't dig too deep. It's just too much data. We're looking to add frequency counts. How often have we seen them across our data set? And so if I can tell you I've seen this 1 million times, that's probably something you're not going to pay attention to. But if I can tell you frequency-wise, I've crawled the web and only seen this 5 times, that's probably very interesting and something you want to dig in. So that's kind of our next step to really distill this data down, is to say, what is the time frame and what is the frequency, and why are they interesting?
So one of the ones I wanted to show you was toy-spinners.com. It's one of the examples in your packets. And I'm going to do a pivot search on this person's email address, Hildegard Gruner. So I'm going to open in a new tab, and we'll take a look. So Hildegard buys up a lot of domains. And if I show 100 at a time, we're showing 1,000 here. So as I go through, we might see something that is another company or a typo squatted domain. USAA-com.com.
Walgreens, Sears.
Yeah, Sears-ca.com, Walgreens. So he just buys them, generates traffic, and sells them.
In this scenario, a lot of times filtering off of last registered and kind of sorting the data that way is really the best starting point. Any other questions? I mean, we can walk through a full host pair. I have a full host pairs example if you guys are interested in that I can walk through. Did that kind of answer your question? Would you like to dive deeper?
Yeah, I mean, like you can't ever back the URL right?
So we don't at the moment, because we kind of strip that out and normalize it, because passive total doesn't have the concept of URLs. We only have the concept of domains and hosts. But we're implementing the concept of URLs, and we're trying to bring more of our crawling data in. And what we're going to start to show you is sequencing data. So how did that sequence take place? What was the redirection chain? Which will give you that context of if you're seeing parent host, child host, how did we make that correlation? Right now we give you the cause of it, but you don't know where it ended up in that chain, if it was part of a much larger chain. So we're starting to add in information like that that'll give you that context. It all exists. Honestly, the biggest issue that I have in bringing new data to the platform is how do I make it so that it exists in the platform and it's usable and it's not overwhelming. I feel like we've done an okay job with it with crawling data. We're now trying to figure out a way to make sure it's a lot more straightforward to our analysts, because I think that's the benefit. You can always get a lot of data, but if I can't present it to you in a meaningful way, it's not going to be helpful. It's just going to be overwhelming. The other thing we're looking at is we have something called known associates. It's our associates list. And so does this domain associate with anything that is malicious in nature? I can start to highlight those associations based on that. So the domain you queried has host pairs that are known associates to blacklisted items. We can start to highlight those things. So there are all kind of these issues that we're trying to flush out to make that data a little more approachable to analysts.
Do you want to run through another example, or do you want to end? It's up to you. Show of hands, another example, or we're going to call, okay, one person. Anybody else?
I would say I'm more than happy to kind of stand here after this and walk through as many examples as possible. If you're interested in sticking around and walking through with us, I'm more than happy to deep dive through a couple examples, and we can all kind of watch on the screen, and I'll drive. If not, I understand it's been a long day, a lot of people talking, a lot of information. More than happy to kind of stick around and answer questions and do some examples. But I think we've exhausted a decent amount of your time. I certainly appreciate everybody showing up. On behalf of our partners, I know we all appreciate your time and your attention. I hope you got something useful out of this. If you have questions after the fact, please come down, talk to all of us. Some of the partners are hanging out in these lovely luxury boxes up here. Others are out in the lobby. Thank you for coming. Much appreciated. Hopefully we see you again soon, either in Columbus or Cincinnati again.
Yeah, so please fill out your surveys, give us some input, because we want to improve these and make them better. And if you have ideas for use cases or different areas that you want us to focus on, like finance, tech, healthcare, education, different aspects, just let us know, and we'll try to get some of those use cases in our portfolio to show you. Okay. Thank you very much for everyone for showing.
Jeremy, are you collecting
surveys?
Surveys?
So fill out your survey, talk to Ms. Kim. She'll give you a tracker tile, and she'll also give you your certification. And then if you want to get your credits, log on and take care of that. All right.
Thank you. Thank you.